Record to the cloud. Okay. Hello, everybody in here, out there, all around the world. Welcome to Advanced Programming with Java here at Portland State University. I'm David Whitlock, and this is weird. The last time I was like in a room with people was like 2 years ago, and actually I was in this classroom teaching this course, and then like everything changed. And we're back. This is great. I've taught the last two times I've taught this course. I've been in my living room or my backyard in the summer. We're here and it's winter, and we're back here in class. This will be an interesting and challenging term, not only from an academic standpoint, but also from like a facilitation standpoint, as we all continue to navigate and figure out this incredibly unusual situation that we're all in. Tonight, we're going to talk about a lot of things, and I just want to warn you now, it's going to be long tonight. The class is scheduled to go 4 hours tonight. We'll probably take most of those 4. I want to have a lot of breaks, though, because, you know, we all get tired, whether we're sitting here in class or whether we're at home staring at a screen or just needing to go outside and, like, take our masks off, get some fresh air, whatever it is that you need to do. Got a lot of stuff to cover tonight. But I hope that it's interesting. Just wanted to let everybody know that this is an Attend Anywhere course, and so we've got the Zoom going for people who are remote, and there are also a handful of people here in the class joining us. Thank you all for attending, for being part of the course this term. I think we've got some really cool stuff coming up for the next 11 weeks. And I hope you all enjoy what it is that what you see and what you do. So I want to start off with just a little bit of framing from the course. So tonight, this is here, sorry, and I haven't taught with like Zoom on the big screen, so actually I'll leave the chat up. So we're going to do tonight, I'll introduce myself and also Michael Hahn, our grader. I'll talk about the course and its syllabus. We'll talk about the content that we'll be learning about this term. I also want to hear from you. A big component of this course is working together in groups. And so then like our first thing is I'd like you to tell me about your experiences learning remotely, learning in this Attend Anywhere hybrid, whatever you want to call it, environment. This is something that you have a lot more experience with than I do, and I need to learn what works for you and what doesn't work for you. Then we'll dive into some Java programming. We'll learn about how you can get started in the course in getting your environment set up, getting the code that you need to develop. We'll get a little lesson in test-driven development, and we'll, time permitting, start doing some test-driven development in our very first Java project. So lots of stuff to cover tonight. I've been known to talk fast. If I'm going too fast or if you have a question, please here in the classroom raise your hand, or let's see here, remotely. I'll try to keep an eye on the chat. Also use the hand raise function in Zoom, and if I seem to be ignoring you, I'm not doing that on purpose. It's probably because I just I'm focused on what I'm doing. So please feel free to come off mute and ask her a question if it's been 30 or so seconds and I haven't noticed yet. Okay, exciting times. So I'm David Whitlock. I've been teaching this course for, my God, over 20 years now. It's such a privilege to be doing this here at Portland State. I'm so glad I have the opportunity to share with you what I know about software engineering, about software development, about the Java programming platform. I am joined in our mutual quest by Michael Hahn. Michael is our grader for this term. Michael, would you come off mute, please, and introduce yourself? Tell the people where you're from.
Yeah, hi everyone. I'm Michael Hahn. I am a second-year grad student.
And sorry, you know what? No one in the classroom can hear you. Let me see if I can figure that out. No, that's my fault. Let's try that. Michael, can you hear yourself again?
Hello. Can you guys hear me?
Yeah, you're coming through the speakers. You sound good.
Excellent. Okay. So hi again. I'm Michael Hahn. I'm a second-year grad student here at PSU. I used to be a mechanical engineer, but now I'm learning the ways of the computer. I took this class over the summer, and it was really fun. So when David was for grader, I thought it would be a really cool experience. So I'm really excited to help you all learn.
Cool. things that didn't really come through so well here in the classroom maybe came through in the recording. You could all watch it to learn more about Michael. We're still figuring out the technical difficulties. And by the way, I'm keeping the audio for the Zoom on my headset, so I can hear a little better. But we'll figure it out. Maybe it makes sense to have it play through the classroom speakers. And again, if anybody has experience like it's like I had a professor that did it this way and it worked really well, let me know. Cool. And the idea of the headset is so that hopefully the audio quality for people who are remote is better than just coming through the speaker on my laptop. So I wanted to start out with talking about the nature of this course. When I was asked to teach this course, I don't know, a couple months ago, they said, hey, there's this option to have your course be attend anywhere. And I said, yeah, I think that's the right option for this course. Even though there is a group component in there, the most important thing to me is your safety, is making sure that you feel comfortable both physically and psychologically taking the course and participating in what we do. And for some people, I know that means being in the classroom. That means being here with limited distractions, not having whatever else is going on in your house or just on your screen, making sure that you can feel fully focused and engaged here in the classroom. I also know for a lot of people, they work much better in a different environment, in a different place, at a different time. And I want to make sure that you can engage the way that you want, especially during these times when we're all worried about our physical health and the health of others around us. So the option that you have, I just want to make this abundantly clear, is to come to the classroom here in Fab 10. We'd love to have you, or be remote. It's whatever makes the most sense for you. And it doesn't have to. And you can choose to come on any given week. Maybe there's a week that doesn't work for you. Yep, attend remotely. But class will start promptly at 5:30 on Wednesdays. It looks like everybody found the Zoom. It was there on the homepage of Canvas. We'll look at that in a little bit too. I will leverage breakout rooms for remote collaboration activities, and we'll figure out for the people who are here in the classroom whether it makes more sense for you to be part of a Zoom call or to leverage this classroom. So this is my favorite classroom in all of Portland State. I've taught all over the place, including the movie theater one time. That was kind of a trip. And I love this classroom because it's got these projectors around the perimeter. It allows us to do pair programming, mob programming really well. It's super fun. I'm glad I got this classroom so we can leverage it. But otherwise, there's also an option for doing all of the group work remotely too. Via Zoom, we'll use breakout rooms. IntelliJ has a feature called Code with Me that allows you to share code really easily. So we'll explore with some stuff, and I do ask that you grant me some grace, and because I'm going to mess this up, and like the audio will be bad, or like the microphone will roll up against my mask or something, and so just please let me know if there's something that isn't working for you. I'll try my best to accommodate it, and I realize that you all are continuing to be students and take your classes under some very unusual circumstances. So we'll get through this together, and I think it'll be a lot of fun along the way, and I hope you learn a lot. Beyond class, I've tried to leverage as many tools as I can to make the course accessible outside of the classroom and outside of campus. So I'm not a full-time faculty member here at Portland State. I have a day job at a company called Tripwire. I used to say downtown, but yes, we still have an office, but I haven't been there in 2 years. So I work out of my home during the day, which means I need to commute down here right before class. And so then all the lecture materials, all of the class sessions, all of this, I'm recording it now on Zoom. I'll post it up to YouTube shortly, tomorrow morning or something like that. And so then you can view the recorded classes. This is so that if there was a topic that either you missed or want to review, or hey, you had something else going on Wednesday night, maybe there's a Felicity marathon that you were caught up on or whatever like that. You can fast forward. You can if you miss it, you can watch the recordings on YouTube. That Felicity joke usually kills. I know. Yeah. Felicity. No. Anyway. So you can watch the recordings on YouTube, and watch them at 1.5 speed or half speed, depending on if you can keep up with how fast I'm talking. We'll also be leveraging Canvas. So for many years I used D2L, and this term we're using Canvas as the learning system whatever it's called. Okay, I started playing with it. It seems pretty straightforward. It's funny, my kids use it in their school, so they're all laughing at me now because like I gotta use Canvas too. But I think we can make it work. And I think Canvas is probably new to number review. Also, I don't know how many of your professors have already started using it. So another thing that's new and exciting and challenging this term, and we'll figure out how to use it together. So I apologize in advance if there's anything that's incorrect or inaccessible. And actually, if someone in the background, if you have a chance or like on break or whatever, check out the Canvas. And if there's anything that seems a little off, actually, you know what? We'll take a look at it here in a short while to make sure that my view matches your view, because I really don't know what I'm doing that much with Canvas. Also, in between classes, I want to be able to provide, myself and Michael will be able to provide as best support as I can for everybody in the class. And so I leverage Slack, and I'll be posting an invitation to the Slack channel. Actually, I think there's also one. The Slack link on Canvas seems to be broken. Thanks, London. I'll fix that shortly. I wonder if it timed out. Anyway, we'll be using Slack for sort of like the day-to-day communication, both in terms of broadcasting out to everybody, saying like, "Hey, your quizzes are graded," or "Hey, there's a snowstorm and we have to rearrange class," or something, or I won't be in class. So we'll figure all that stuff out. It's also an opportunity for you to ask questions about your quizzes and your projects, the assignments, what's going on in class, various topics. It's a way for you to all communicate. So those are some of the tools we'll be using, and this is how we'll try our best to accommodate this very unique and different learning environment. I wanted to, this is usually where I say, "Oh my gosh, the course is very registered full," and lots of other people. Actually, that's not the case this term. It's nice. I have a very manageable student load, which I'm looking forward to because it allows us to explore some more topics. It allows me to give you higher bandwidth communication and better support. But really, my goal here is to provide a good learning experience for you. And everybody is different, and everybody is facing different challenges right now. So please let me know how I can best help you along this journey as we learn about Java, as we learn about software development. Okay, that's sort of the intro. Any questions before we get started? If you've got a question on Zoom, please post it in the chat. But anything I can answer people in the classroom first. Nope. Cool. Okay, well, let's see if we can fix that Slack link first of all. So let's look at Canvas. So this is Canvas, and the class homepage. The intent here is that, and actually, I'll just post this in the. I'll post this in the chat. And those of you if you have a laptop here, feel free to join the Zoom. I guess you don't have to get on audio or anything, but you can get the Slack that way. And let me know if you can get the chats that way. Let me know if there's a better way for me to get that to you here in the classroom. Let me let's see. Do I have Slack open? I do not. Let me quick open it up and I'll show you Slack. Slack is loading. So here is the Slack. Let's see your copy edit link. It says expired in 5 days, so it should be the same one. I wonder if it appears to be the same one. So let's see here. London, let me just save this change. I wonder if I didn't get the URL right or something. Link. Save. Actually, I'll also paste it here. So could someone try that link and see if it works? I don't know if it's just you. I might have had the link wrong on the website. It says not active. That's weird. Really? I wonder what I got wrong there. is working now. The one posted on Zoom. So Patrick had to work. London. Okay, if you try it again, London, or maybe the one that I posted in chat. If not, I can follow up with you afterwards, maybe, and add you directly via your email or something like that. Oh, I've got 3 people waiting in the waiting room. Is that ticking noise? It's super annoying. Cool.
I think that ticking noise is people joining Slack.
Was that Slack? Okay, that would do it. Okay, cool. Excellent. Looks like London's in. Great. Okay, so join the Slack, and actually I'm probably seeing people show up all right now. Oh yeah, that's all the ticking noise there from my Slack. Oh, and actually you're probably hearing that because I'm sharing the computer audio. Let me, can I turn that off real quick? That's probably gonna, there you go. It's probably gonna get super annoying. Great, everybody's joining. Yay. Okay, excellent. And so just to give you a tour of the Slack environment, I've set up a number of channels. This is the way I like to organize things. You know, I know there's some people that just like, well, one channel with all this stuff going by. Sorry, that ain't me. What I do is I have channels set up for the general topics for the course. So when I post class recordings and stuff, I'll post them here to the class recordings channel. And so please, be sure to sign up for all this stuff or the things that you really care about. Any questions about getting started? We'll see the whole getting started repository thing tonight. You can post that here. And then I have channels for the quizzes. For each project will have its own channel so that you can ask questions that are relevant to that project. That helps you find the information that you want. It helps me answer the questions in the appropriate context. So good. It looks like we've got lots of people signing up for that. Okay. Also here on the course homepage or on Canvas. So I use Canvas for assignments. Content for the course lives someplace else, and that's on my my PSU homepage, which is right here. So I'll click on that, and it'll open up here. For me, boy, I've been teaching this class so long. We didn't have fancy tools like Canvas, 20 years ago, and so like I just use the website for all of this. And so this is the definitive source for all of the information in the course, including links off to the screencasts. Sorry, is this big enough for everybody in the classroom? Can you all see this okay? Yeah, okay, good. Okay. You can get links off to the to lecture notes, off to the screencasts for the lecture notes. And so then I ask that you all come prepared to class. Having read all this stuff, we'll be talking about them in class. We'll open up. If you have questions and stuff, ask them on Slack or do it during class time. It's all good. So anyway, so each week there is an overview. Actually, let me post this in the chat too for anybody who isn't playing along at home. Each week you sort of get a guide to here's what you can expect. A little bit of prep work. I've also tried to call out all the quizzes and stuff. We'll talk about the syllabus and what all that means. But so there's stuff here on the homepage, and I've tried my best to also place it here on the calendar in Canvas. So I think this is everything is up there. So every class meeting ought to be on your calendar, as should every quiz, the plan of attack. We'll talk about that next week, and also project assignments when they're due. If you see something that looks wrong or whatever, please let me know. Again, this is my first time using Canvas. I'm trying to figure it out. My goal here is that even though things aren't your projects aren't submitted through Canvas, the quizzes are on Canvas. I want to make sure that all the information is visible to you, and so that if you're using Canvas calendar for your other courses, I want this course to be on there also. Again, please let me know how it goes. I'll try my best to make sure that you all are aware of what you're responsible for so that you can plan your time accordingly. Yes? Question was, quizzes are not on D2L. So no D2L in this course. We're using Canvas instead because it's the year 2021, the year of the Canvas. D2L is going away. So I don't even know if D2L is available to other courses this term. It might be, but this course is in oh, really? Yeah, so it's all Canvas this term. And I don't know exactly what the quiz experience looks like. As a matter of fact, I think the first quiz is open for anybody who wants to take it. It's all about your programming background and stuff. So there's no like Java content. And I guess if something isn't working for you or something is surprising, please reach out to me to let me know. Cool, good question. So this is the class homepage. All of the information that you need ought to be here, but please ask me if there's something that you don't find. Okay. What else? Let's go back to the. How do you navigate this thing? You go to courses and you go to this. Let's go back again to the Canvas homepage. This is mainly stuff to get started. Oh yeah, right. Link to the Zoom. So you can find the Zoom here on the Canvas page. It looks like many of you did, which is good. Also, the class's YouTube channel, which is empty right now. This is where I'll put all the recordings of class. There are a couple of YouTube channels. There's the one for the lectures, and there's the one for the class recordings. The one for the class recordings, and then the link to Slack, and then more details about Zoom. Also, just some notes here. It's my statement about what it means to be attend anywhere. And just, again, please be patient with me as I figure out how to do all of this stuff. And then just a couple of notes here about using Canvas. Some of this stuff might not make sense to you right now, but it will by about week 3. I've tried really hard to make sure that I'm not holding you accountable for anything that you shouldn't know how to do. Okay, I want to dive into the syllabus next, but any questions are about the mechanics of how the course is delivered or any of the tools that we'll be using to deliver the content? Okay, cool. Hey, Michael, thanks for hanging on. I think you're all set for tonight, so it's Miller time. I don't know.
All right, thanks, David.
Please don't drink Miller beer. Yeah, you're better than that. Cool. Nice. Okay, let's talk about the course syllabus. So by the way, a lot of the stuff, like the assignments and everything, are PDFs up on my website. So welcome. So this course is advanced programming with Java. And so then, the advanced programming part is all about some of the software engineering techniques like automated build systems, continuous integration servers, test-driven development, unit testing with mocking, all sorts of great stuff like that we learn in here. And we do that in the Java programming language. So then, I hope most people are at least a little familiar with Java from your other courses. So while we won't be getting a super deep refresh about Java, you will be seeing me doing a lot of coding, and of course you'll be doing a lot of coding yourself. But be aware that you're not only learning software engineering techniques in here, you're also learning a programming language and a programming environment in Java. And what I hope that you ultimately get out of it is learning a lot of good stuff and having some fun while you're doing it. I don't see myself in a green mask. So how are we going to do this? Well, we'll have lectures that are delivered online. Those are the YouTube videos. Also in-class discussion, both here in person and remotely, and through pair and mod programming. This is a good way to learn, a good way to explore writing code with others. You're going to see a lot of examples of code throughout the course, both in the lectures, but then also the stuff that I develop and we develop together. And you'll be able to demonstrate that knowledge in a couple of ways. The first is the multi-phase project. We'll see the first part of that tonight. And then we also have a series of quizzes and exams that occur throughout the course. There's about an 11-week course. There is a quiz almost every week. There are 6 phases to the project. And so you can look at the calendar to sort of see how they're staggered. I'm not going to kid you. There's a workload in this course, and as I say later on, if you're taking other like program-intensive courses or something like operating systems or compilers, which I don't even supposed to teach compilers anymore, make sure that you have chosen a workload that meets your abilities and the circumstances that you're in. What we're going to talk about, well, the lecture materials cover a broad range of subjects. The Java language syntax, of course, we'll be seeing a lot of Java code being written too, so that's a good way to pick up the syntax. We'll learn about object-oriented design and programming. We'll be writing our own classes, and then we'll be leveraging a lot of classes that other people have written. you'll see the standard Java class libraries. So you won't have to write your own linked list class in this course. You can use somebody else's. Also, the facilities for doing I/O, for doing date formatting, all kind of standard stuff. But it's good to see it with the Java flair. We'll also be learning a lot about testing in this course and getting lots of experience writing tests for our code. So we'll learn how to unit test Java programs. We'll see some stuff about integration testing also. We'll learn about test-driven development and the benefits and getting you experience in writing tests before you write the code under test and what that's like and how that can work and what the pluses and minuses are. And we'll also learn about building Java projects using Maven. But from what my students tell me, the code that you write in this course is more complex than in some of your other courses. And actually towards the end, we'll be seeing stuff like doing Android applications and building web applications and things like that. And Maven is a good tool for assembling all the pieces parts together and saving you a lot of time up arrowing on the command line. And then in the second half of the course, we move beyond just command line applications to develop web applications where you have a REST service that's called by a client. We'll also be learning about more advanced topics like Java reflection and dependency injection, that design pattern. And then we'll cap everything off with a couple of weeks focused on Android development, which is in the Java programming language, but then those programs are deployed not to your desktop or not to the Linux machine, they're deployed to an Android device. There's a lot of stuff to cover in 11 weeks. However, normally I cover most of the stuff in an 8-week course. I'm glad that we have a couple of extra weeks. It'd been a long time since I had taught the 11-week course. I did it 2 years ago, and it was just nice to have a little bit of extra space. Summer is always very hectic. It's kind of rushed in places, and but here in the winter, we can explore some topics a little more deeply. I found that the students have some more breathing room in terms of their projects. So even though there's a lot of content, a lot of this content might be new to you. I think the class is very achievable, and I'd like to think that we're offering something unique, both in terms of the toys they get to play with, and then also the concepts that you get to explore. So that's what we'll be covering in terms of topics. Grading policies, always important to know up front how your grade is going to be determined. The vast majority of your grade comes from the projects. This is an applied course. We're not here to learn about set theory. We're not here to just draw pretty pictures. We're here to write code. And so then the majority of your grade will be determined by the multi-phase project and a project called the Java Koans that you'll build up over the entire term, starting tonight. We'll see project 1 tonight, and you'll start working on project 1, well, hopefully very soon. During the course, there are 8 quizzes that you take. The quizzes are on the content that's covered in the lectures and in class. We dropped the lowest grade in case there was a concept that you didn't get, or you're just having a bad hair day or whatever when you took the course. So there are actually 8 quizzes that you take. 7 of them count. That's 21%. All of the quizzes will be administered online using Canvas. There are also two activities there are activities in pair programming and mob programming. I believe in the 11-week version of the course, there are 6 opportunities. Yes. There are 6 opportunities for pair or mob programming. I believe you have to attend 2 of them. And again, it can be in person or online. This is where you'll get to code with others. But what you're assessed on is a reflection on your experience. So it's not about the code that you write in an hour and a half in class. It's about the experience that you have. And those are also administered. Oops, that should be via a Canvas quiz, not a D2L quiz. Those are also those reflections are administered via a quiz on Canvas, and we'll talk more about those, I think, week after next when we start doing pair programming. There is a final exam. It is given on the last day. It's worth 12% of your grade. So there is a final exam. It's something you need to study for. It is cumulative, but it's worth 12%. So even if you don't do well, and so then the bottom line is that your grade is not determined on the last day. Your grade is determined throughout the entire course. So I'm a firm believer in giving lots of people a chance to contribute to their grade. And so then if you're one of those people that likes to, do nothing during the course and then, stay up all night cramming at the end, this isn't the course for you. We do things gradually here. So there are projects, and I want to, so all of this stuff is work that is due or is assignments, and I want to clarify like what my policy and what my stance is on late dates. So they all have due dates during the term, and the due dates basically determine once we start giving you feedback. So like when I have Michael grade things and all of that. So you have 2 late days that you can use for project submissions, and you can use those on any project at any time. And don't worry about letting me know if they're late or not, because I will know. We'll talk about the submit script next time, and you'll see how all of that works. You can also request that one project be regraded. So hey, let's say that you like fundamentally misunderstood what the project requirements, like all the test case fail. Well, I don't want to give you a 0. Instead, that's an opportunity to say, oh yeah, right, okay. It's probably like a 1-line change to fix the problem, and then resubmit it, and I'll regrade that. And you can do that once during the term within one week of the original grading. I don't want you saving up to resubmit until the end of the term and then have to make the grader go back and like regrade a project 1. Nope. This is like, oh yeah, right, I made a mistake. I'll fix it quickly and move on. Otherwise, I don't accept any late work. Now, that being said, we're still under very unusual circumstances. If if you get sick, or if you're taking care of someone who is, or just like life is really challenging, reach out to me as soon as possible. Let me know. I'll work with you. Ultimately, I want people to succeed in the course. Ultimately, I want people to learn and to derive value from what they're doing. And I know that can be really difficult in the situation that we're in right now. So, if you're struggling, please don't give up. I'm here to help. Other people are here. I can help you with this course. If you need help in other aspects of your life, I probably can't help you there, but maybe I can get you in touch with someone who can. Like I said, safety is our number 1 concern, and I'll help you. I'll try as best I can to make sure that you have a safe experience during this course. Let's see. Oh, and people always ask, is there a curve for the course? Yes, by policy, but usually there's not much of a curve. Hey, if I find that one of the sections, either graduate or undergraduate, has like a really weird distribution, I'll adjust. But I've optimized the course enough over the years so that most people do fine, some people don't, and it fits pretty well to the standard grading range. So if you're like, wow, overall I have a total of about 97, yeah, you're doing pretty good in the course. If you're a 30, you're not doing well in the course. Yeah. The question is, do I ever curve down? Yep. Oh, again, it seems, so the question is, hey, wow, look, the average score in the class is a 97. First of all, that doesn't happen that often. Actually, I don't think it's ever happened. No, I'm not inclined. I mean, so you don't need to worry about that. Again, if you're doing, really well on all the assignments, you got nothing to worry about. I'm not going to, I think this stuff is hard enough as it is. And hey, anybody who can jump over those hurdles deserves a good grade. What a great problem to have, right? Yes, everybody's awesome. You all are. You're all capable of it. Let's see here. Yeah, I said it's possible that the curve may result in grades lower than the standard grading scheme. It's never happened before. But here again, I feel like I have to be kind of legalese and lawyerish here. Also, even though there are graduate and undergraduate sections of the course, the content is the same. The grading policies will be the same, but each section is graded on its own curve. So basically, you're not getting the undergraduates and graduates aren't necessarily going to have the same letter grade. They might, they usually do, but I reserve the right to say, hey, listen, the graduate students have a different shape to their curve than the undergraduates. Any questions on grading policies before we move on? Nope. Okay. For many years, I had no problems with cheating. And then lockdown happened. And so there's some things I need to reiterate. regarding academic integrity and cheating. Don't do it. I know you might think you're being smart. Nope. I've seen it all. I've got tools to help me. Please don't do it. If you're having problems in the course, if you're like, oh my gosh, I need help, or gee whiz, I'm just trying to get this one thing done, let me know and I will help you. Please resist the urge to either work with someone who's currently in the course, formerly in the course, or code that you might find on the internet that is related to the course. I've found it all. I've seen it all. Please don't. Please resist the urge to plagiarize. Like the department policy says, it's cheating to submit for credit work that you did not create or allow your work to be submitted as the work of another student. So again, if you find someone else's code, say, well, it's very nice, and forget about it, and make sure your code is your own. Now, that being said, I don't want you to feel that I am that I don't want you to talk to each other. I know it might be hard in these circumstances. But please, if you're, well, like the image that I have in my mind is like, great, you're all like, hanging out on the quad and playing frisbee or whatever the college kids do, and you're talking to each other about your courses. Good, do that. If you're, hanging out in the lounge or whatever, and you're drawing pictures on a whiteboard, that's totally cool. But don't look at anybody else's code. Don't search, and please, we'll be using GitHub repositories for our code. Keep them in private repositories. Don't post your code in Slack or on not Twitch. What's the gaming chat thing that like Discord? Thank you. Don't put stuff there. Share ideas, answer questions. Hey, it's okay to look at like Stack Overflow and things like that, but just don't copy each other's code. To further emphasize, there is some work in this class, in particular the pair and mob programming work, which is explicitly collaborative. That's when I want you to look at each other's code. That's a great opportunity to like share design patterns or like to talk about how certain classes work and things like that. Yes, that is when you can work together, but everything else, including the quizzes and the projects, and I can't believe I'm overemphasizing this, is your own work. Please don't look over each other's shoulders for doing that. But most importantly, if there's a question or a concern, or you're like, I don't know, can I work with this person this way or not? Ask me, and I'll be happy to give you a ruling on it, because it might be okay or it might not be. And because I've had problems with this, I want to refer you to PSU's statement on academic misconduct. And so it's right here. I'm sure it makes for compelling reading. Okay? So is anybody going to cheat? No, you're not going to cheat. Good. Okay. Lots of other things. Lecture notes and screencasts, as we already saw, they're up on the website. Please, in between classes, review them. This is like your textbook. This is like, what you do to prepare. So yes, there's a textbook for this course. I don't follow it. I haven't read it in years. It's probably really old by now because, my gosh, it's the 21st century and we have way better, or rather we have lots of ways of learning. I want you all to find the way that works best for you. Please don't wait until the last minute to start the projects. Some of them might seem easy, especially at the beginning. Experience shows that they're not the kind of thing you just sort of start the night before and then just bang out. So please get started early on them. We'll talk more about this next week, but I have some requirements about documenting your code. I recommend that you document your code as you write it. So, think about it in your head in terms of words. It'll make it much easier to express in Java. Please ask questions if you have them. I love hearing myself talk, but I can go back and listen to the old recordings of me talking if I wanted to hear myself talk. I'm here for you. I'm here to convey what it is I know and what I think you ought to know. And if there's something that you don't understand, please let me know, either here in the moment or feel free to follow up with me afterwards in Slack, via email. I'm here for you to aid you in your learning experience. I mentioned this at the beginning. I want to reiterate it. It's a senior level course. There is a good amount of work here. It's a graduate level course for graduate students. If you're taking a heavy workload, you might want to reevaluate your schedule and make sure that what you're attempting to bite off this term is something that you can achieve and feel good about and succeed in. I've given you a lot of code examples. We'll see how to access those shortly. Go home, play with them. Sorry, good question. Yes. Oh, how many hours on average? I don't have a good feel. I've never taken the course before, and so I found that it really varies by student. I think what I can quantify is like the lecture material. So that's probably about 2 hours at 1x speed a week, maybe 3 at the beginning, and then the assignments, somewhere between 6 and 12. Especially at the beginning as you're getting your feet wet, as you're learning the tools and everything. But maybe that's something that we can gather some data on this term. I don't know how best to do that, but maybe you start a Slack with me or something like that. We can send out a survey or something and say, hey, how long have you spent on this project? Because yeah, I honestly don't know. But I think that's very important, and valuable information for you all to have to help inform how you plan your time and your work in this term. Oh, yeah, I'm sure IntelliJ has a plugin or something, yes, where you can record how much time you're there on test. It's a good idea. Yeah. Let's see here. Oh, office hours. It says the hour before class on Zoom. I don't know if I can make that happen this term or not, because I need to leave work at home and then come down here. I will get back to you all on that. In the meantime, if you need anything, contact me, and there's ways to contact me. So my email, my PSU email or the PSU email that I tell people about is whitlock@cs.pdx.edu. Note that there's another David Whitlock at Portland State, or at least there used to be. I don't know if he's still there or not. That is whitlock@pdx.edu. He's over in the art department or something like that, and is probably very confused by questions about Java. So if you email me and don't hear back, double check to make sure you send it to the right Whitlock. If you use my PSU email, that's whitlowcd@pdx.edu, and that is and I'll see that. It's also like what I use for all the other all the Zoom and everything like that, and that comes up as David Whitlock Comp Sci to differentiate myself from Art School David Whitlock. And finally, sorry, a couple more things. We found that in recent years, some of the emails from the grader might be marked as spam. So if like I Slack everybody and I say, hey, your project one's been graded, and you're like, I didn't get a project one. Please check your junk folder for communication about your project grades and other things like that come from the grader. Again, that's the class webpage, and it's the authoritative source for all information. We'll talk about this after the break. There's a survey program, it's a survey script that you run. It's very important that you run this very early in the course, because it tells me who you are, it gives me the information that I need to enter your grades. You only need to run it once. And we'll talk more about that, like I said, after the break. So that's the syllabus. We talked about what it is that we're going to learn, how you're evaluated, don't cheat, and a whole bunch of miscellany. Any questions before we take a 10-ish minute break? Nope. Zoom people, so far so good. Please feel free to use the reactions to tell me how things are going. Thumb up from Eric. Okay, Addison, thanks for weighing in. Good. Yeah, Ming, Patrick. Okay, excellent. Good deal then. Okay. Yeah, let's take a break. I'm going to pause the recording for about 10 minutes. We'll be back at about 6:25 p.m. Recording. Okay, welcome back, everybody. Hope that break was okay. I try to take at least one break every hour and a half. It'll be a little more frequent as we all try to pace ourselves to get us through these long times and make sure that everybody has an opportunity to stay focused, hydrated, all those good things. A little bigger. Okay. So let's dive into it. So I've given you an introduction to the course. We learned about the syllabus. Let's start doing some work. So how many of you, and let's raise hands in the classroom, and then I don't know, some reaction here on on Zoom. How many of you have used GitHub before? Everybody in the classroom. Lots of people. Okay, good. So it's a tool that you're familiar with, and so Git and GitHub, I'm big fans. You know, back in the old days, when it came to sharing code, it was tough. You were copying files around. I remember being in college and submitting my assignments on floppy disks. It's all kind of crazy. But now we have really great tools for sharing code and for revision control. And we'll talk more about like what all this means later. But GitHub is really great. And so then to help get you started with the course, I've created a GitHub repository that you can work with and basically make a very special copy of it for yourself and do all of your work in there. It's got some scripts to make things easier and sort of gives you an environment to play with. It makes it pretty straightforward to then move your code from your local development machine to the PSU machine, so you can submit it there, but still work on your laptop, work on your desktop, whatever it is, you know, whatever environment that you want to use to develop. So let's see here. So let's get started on that. So there is the Getting Started GitHub repository. So I'll open that up. So this is a GitHub repository that's under my account, and it has a big old README that gives you everything you need to know about getting started in this course. I'm a big fan of hyperlinks, as you can see. And so what I'm going to walk you through right now is how to use Git. I'm not going to install software. You can do that on your own. But I do have some links to go off and to download things like Git so that you can use GitHub, IntelliJ so that you can use that, the Java development environment, all of that kind of stuff. So let's see here. So I'm going to work on the command line. It is possible to do some of these things through IntelliJ. IntelliJ has really great GitHub support, but I do most of my like day-to-day Git stuff in IntelliJ because it makes it really easy. But to get started, I'm going to use the command line. So here I have my command line environment. Let's make sure I've just got Git here on my execution path. I do. Let's see what version it is. 232 ought to be sufficient for what we're doing. Oh, and by the way, right. Okay. So I recommend that you create a student developer account if you don't already have one. This gives you free private repositories. Now, repositories in GitHub can be public or private. Public means that everybody on the internet can see it, which is great if you're an open source project, not good if you're a student in this course. Right, the code that you write should be your own. Well, when we do the pair programming and mob programming, that can be in public repositories, no problem. But your project code, which is what we're going to be focusing on tonight, should be in a private repository. So then you follow this link right here, and it gives you the instructions for creating a new repository, and just choose I'll choose a private one. We'll do that right now. So you go up here in GitHub and you say create a new repository. I'm going to open it up in a new window. I am going to call this, now I'm going to make mine public so that you all can see it. Yours should be private though. So you're going to choose the private option. I'm going to choose the public option. I'm going to call it Portland State, one word. Oh, sorry. I'm going to call it, and so there's some noise in the background here. I'm going to mute you. There you go. I'm going to call it Portland State Java Winter 2022. Description, I'm not going to add one right now because it's going to get one later. Mine's going to be public again. Yours is going to be private. Don't want to add a README. Don't want to add a git ignore. And the license, we're not going to do that either. So there's a plain old vanilla repository. You can call yours whatever you want, but Portland State Java Winter 2022, I think is a fine name for anybody. I'm going to click Create Repository. So this is going to create a repository, an empty repository, and it's going to tell you, oh, look, Joel's command line stuff. Don't do this exactly. I've got some special instructions instead, because what you're going to do is you're going to make a copy of my Getting Started repository into your working repository. What this will give you is all these scripts for creating your projects and submitting your projects and things like that. So this is an environment for you to work in. It's in GitHub, and this is a way for you to get started with all of that. And all of this is covered in this how to get started or how do I use this repository section here in the README. So we created a repository named Portland State Java Winter 2022. Don't initialize it with a README, like I said, and do make it private. Also, do note that if you want to make your repository public, to say, hey, here's the portfolio code that I wrote. Maybe you're very proud of some of the code that you wrote here. That's fine. I can't stop you from doing it. Instead, I say, hey, listen, if you're currently taking the course, don't look at anybody else's. So you can find, there's old students who have their code out there. And I support them in that. It's great. It's good for job interviews. It's good for, playing with and demonstrating what you learned here at Portland State. I can look at those. You can until you're done with the course. That being said, if you want to make me a collaborator on your private repository so that I can contribute to your repository, please feel free to do so. This really helps if you've got a question on the project or like, hey, I'm seeing a bug, can you help me with it? If I've got time, I'll help you out. We can collaborate using GitHub. It actually works really, really well. So I encourage you to do that. Okay, so we created this, close that. We created this crazy empty repository right here. And now we're going to do some magic commands that what we'll do is it'll end up with you having a copy of my repository for you to use. So the first thing that you do is create what's called a bare clone, B-A-R-E, of your GitHub repository. Right here. I'm just going to do this here in my Git directory. And what this does is it creates a file called Portland State Java Getting Started. Portland State Java Getting Started .git. It's a directory with like kind of some wacky Git. It's a bare check out of the Git repository. Don't worry so much about that. So it gives you this directory. And so you CD into that directory. Why did I? Yeah, there you go. And then you perform the following. You say git push -- mirror. What this will do is it's made this local copy of my repository, and then it will take that repository and push it up to the repository that you just created, which you replace here in the command line your GitHub user with your username. Mine, of course, is David Whitlock. Yours will be whatever your GitHub user ID is. Sorry. I have no idea what my password is, but what I'm going to do instead is I'm going to use, so most of you all will use the HTTPS protocol. I use SSH keys because I don't know what my password is. Question over here? The question is, do you need to use your PDX account for GitHub? You use whatever account your GitHub is. So I don't think there's one tied to your PSU. So if you create like a student developer account, just use that one. Doesn't matter what it is. I will then copy this URL here and use this one instead. Nice. Oh, I need to delete that branch. Anyway, so I just did those pieces of magic. So what did I do? Well, first of all, and here again, this is something you'll need to know here on the first day. You make this fancy local copy of the GitHub repository, and then you do this git push -- mirror, send it up to GitHub, and now this is the way my repository looks when it was first created. When I reload this page, it now has all of the changes from my other repository. So this is the Getting Started repository. Now I've made my own copy of it, and you'll do the same. Your repository will be private instead of public. Don't know if anybody's playing along here at home in the classroom. Is anybody on Zoom following these steps in real time? And is anybody who's doing that encountering any problems? Okay, good. So I'm seeing, it looks like everything's okay so far. I can't tell if people who are saying yes are encountering problems or not. Let me know if you are encountering problems. Okay, no one so far. And of course, feel free to follow up in Slack, especially in the Getting Started channel. This would be a good place to reach out to me and your fellow students all about that. Oh, so James, thanks for weighing in on the Slack invite link. I think I fixed it on Canvas. If you could please reload the Canvas page and try it again. I also posted it up in Slack a little while ago. I'll post it again. I think that should work for a couple more days anyway. Okay, so now we've gone through and we see here. Sorry, we did all these commands. Now I have on GitHub, I have this magic repository. Now I want to make my own copy of it here on my local machine. So I don't need this -git directory anymore. Oops. So I will remove that. With forcing it, good. And now what I'll do is I will make my own checkout of my new repository. This will be my one for the winter. And again, I am going to use the SSH version because that's the one that I like. You can use whatever you want. I found most students just use the HTTP one because they don't mind entering their password. I have no idea what my Git password is. I forgot it long ago. Here we go. Everything works with keys. And now I have a, let's see here, winter 2022. Now I have a local checkout of my directory. I've got files like my README and the license, and these are all the files that are here in GitHub. So this is how GitHub works. You're probably familiar with it. You use this tool called Git to basically make local copies of your source code. And of course, what you can do, well, actually, no, I won't get ahead of myself. So now you've got a copy here locally that you can work with. So what are some of the things that you can do with your source code? Well, or rather, with this repository, you'll be able to build your projects and stuff. But in order to do that, you need to use the Java Development Kit. So the Java Development Kit gives you the tools to build Java. The course requires at least Java 11. Anything I've tested it up with Java 17, which I believe is the latest. And so then you can follow directions down here about how to install the JDK on your personal machine. Actually, sorry, and let me post the link here. We're looking at the information in the repository. One of the things that you should do immediately is make sure that your PSU environment is set up to work with Java. So let's see here. Oops, there you go. I'm going to log into the Linux servers, and so then you SSH to your username at linux.cs.pdx.edu. That'll get you onto one of the Linux clusters. If you're maybe new to PSU and don't have an MKX account, please reach out to the CAT, and there's some links on my course homepage about how to do that. You can also ask about it in Slack. I'm sure, hopefully there's someone in the course that knows how to get in touch with them. They're really awesome. We'll get you set up. Oh, you can also email them at support@cat.pdx.edu. So here, make sure that your Java is configured to at least Java 11. And if you haven't worked with configuring your environment in Unix, there is this tool called Add Package that gives you. Oops, there's only one of them. That gives you this sort of ncurses environment where you can select. Let's see here. You don't want Java 8. Instead, you want. Sorry, where was it? It wasn't Maven. Oh yeah, OpenJDK 16. I think this is the thing that you want there. It always it always takes a couple of days to get everybody configured all the right way. So please do this as soon as possible. Make sure that when you run the Java command in the on the Unix machines, that it finds it and that it's at least Java 16. Amelia, thank you for raising your hand. Could you come off mute and ask your question?
Hi.
Whoa, there's a lot of feedback there. Interesting. I wonder why we're getting feedback.
Sorry.
It's all right?
Can you hear me okay?
It sounds great. Thanks.
I have been muted.
Yep, you sound good. Can you hear me?
Yeah. So I actually raised my hand a while ago.
Oh, I'm sorry.
Something that, but it was like, it doesn't matter anymore.
Okay then. And if the question comes up again, or if you have another question and I miss it, please feel free to come off mute or chat me. I can see the chat out of the corner of my eye. It might be easier.
Cool. Okay. Thanks.
Apologize about that. Okay.
Okay.
Okay. So again, make sure that your environment on the CX Linux machines gives you at least Java 16. Okay. So here's some instructions on how to configure a Java both for the Linux PSU machines, which you'll need to submit your programs, and then also on your personal machine. I like the adopt.jdk.net. This is a nice way to get the OpenJDK binaries super easily installed. That works really well. Okay. So the reason we have this repository is, first of all, is to give you a Git environment to work in, but also it gives you a bunch of scripts that make your lives easier, especially when it comes to creating projects. And so what we're going to do, we're going to walk you through right now, is creating a what we call Project Zero. Project Zero is not something you submit. It's a little it's a little toy application that gives you an experience, gives you the environment, actually gives me the environment to demonstrate how to do Java development for this course. Oh, this is kind of out of order. I think the thing that I want to do first is I want to run the survey program. And before I do that, I want to get my code not only here on my local machine, which is on the left, but I also want to get it here on my PSU machine. So I am going to once again clone my my repository. I'm going to clone it here to my PSU machine. Actually, wait a second. Let me. I'm going to run SSH agent. I'm going to say add this, so I only need to enter my passphrase once. Question from Drew: can we use Java 17? Yes, you can. Yep, that ought to work. Let me know if it doesn't. Okay, now I can clone my GitHub repository. Don't need to enter my passphrase. Cool. And so now I've got a Portland State Java Winter 2022 directory with all my stuff in it. Okay. I mentioned this on the syllabus, so now it's time to get into details. There is a script called survey, right? It's right here. Oops. Good. Which asks you some questions about yourself. And then what it does is it generates a little XML file, which gets emailed to me, and then I use that to record your grades, to reach out to you. This is how I know what your email is and things like that. Actually, let me just talk through this here. So one of the reasons that I've been able to teach this course for so long, and I've been able to offer it to so many students and offer 2 sections of it, is that I've tried to automate all of the toil out of it, all of the drudgery things that I have to go through, all like the clicking and the moving of files and everything like that. I've tried to automate it as much as possible so I can focus on teaching and providing the students with feedback. And I want the same thing for the grader, right? Michael is a nice, smart guy. I don't want him spending his time clicking and dragging files all over the place, or doing a bunch of extracting submissions from emails or something like that. So I've developed a couple pieces of automation to help me, and the first one here is this survey program. So the survey script must be run from the CS Linux machines. As a matter of fact, if you try to run it from survey, it tells you that it must be run on one of the PSU machines. And so when you run it over here on the PSU machine, it asks you some questions, and it asks you like what your first name is. And by the way, again, needs to be done on the PSU machines. And if you haven't configured your Java environment yet, it's not going to run right. So put in your first and last name, nickname, sure, call me Dave. My MKX login is Whitlock. My email address, you can put in any email you want. This is the way this is where the address that I'll send your grade reports for your projects. Also contact you if I need to reach out to you, if you're not on Slack or whatever. This is why I want to know what your email address is. So mine is whitlock@cs.pdx.edu. My major, CS major, I'm enrolled. Let's say I'm an undergraduate, and I hope to learn a lot in CS4 10J. And nope, nothing else I want to tell you. So this is where I hope everything works. It gives me a little prompt to say, hey, it tells me a couple of things. It saved the student XML file. So there's a little XML file that describes you. Basically, it's all the information they just put in. And just can ask everything to confirm. So the answer is yes. So I'll say yes. And then what it does is it emails information. Oops. Oh yes, yeah. It tells you to. It says an email to the course grader, and I also get a copy for myself. And what it creates is this little file called me.xml. This is a little XML file that that describes you, and this is important for two reasons. First of all, this is a file that I use. I take that email. It was emailed to me, but you can also use it here to then submit your code, because it tells me everything I need to know about you, like what your email address is and what your ID is and all of that, or what your login ID is and things like that. So this helps save a step and actually a lot of errors that have happened over the years, so that everything's nice and consistent. So run the survey program. Oh, sorry, question from Patrick came in. Same question, is latest for Homebrew? Yes, that ought to be okay. Let me know if there's any problems using Java 17 with the code. Again, though, anything later than Java 11 ought to work. And so I've added this file called me.xml, and now we're going to see our first example of using Git. So I'm going to run the git status command, and that will tell me, hey, what files have changed in the repository. It tells me there's an untracked file called me.xml, so I will do a git add of me.xml. And now I will commit. So now if I do a status, it says that there is one file that is ready to be committed. And so I will say git commit, and I'll say added the me.xml file. Well, actually, do I have an example here? Yeah, there we go. Add information about myself from the survey program. Sure. I'll just copy that. Actually, do I need? Oh, yeah, right. Do that, and then I'll say git push. So just to reiterate, so git commit, what it does is it says, yes, these changes that I made, put those in the local repository, and then git push will push those changes up to GitHub. So that sends things up to GitHub. And now if I go over to my Winter 2022 repository and I refresh the view, you'll see here that the latest commit is not 4 days ago. Instead, it's 29 seconds ago. So that's the latest. So I made a commit to my repository and I pushed it up to GitHub. And I made a change to my GitHub repository. And if I want that here in my local checkout, again, my local machine is on the left. I have remote SSH'd into the PSU machine here on the right. I can do a git pull, which will then get that change down here. And now I have a file called me.xml. And that is, in a nutshell, is what you do with a Git repository, right? You make changes to your code locally. You say, yeah, these are changes I like. I want to commit that to my repository, and then I want to share it with other people or share it with myself on a different machine. I do a git push, and then on the other machine, I do a git pull to get it down from GitHub. Cool. So now I've got the me.xml, and the me.xml file allows me to run the submit program that we'll look at next time. But that is an important first step because it lets me know who you are, and it gets you ready to submit projects later on. Okay. Well, now that I've done that, I can create my first project. I'm going to do that over here on my local machine. So there's a script called create project 0. And actually, did I? Okay, so you can just say, so you know what? I have a little bug here, not a bug so much as an extra step here in the README. I changed it recently so that you don't need to add your mkix user ID. Instead, it'll just look for the information from the me.xml file. So I think you can just run the create project 0 script here, and what it does is it goes off and creates uses something called a Maven archetype to create a brand new project for you. And so it creates a project in the called student, and it's in the student directory. So there's a directory called student, and it has all sorts of information. It has something called, there's a script called Maven W, which is the Maven wrapper. So Maven, and you can learn about this in the lecture, Maven is a tool that builds Java applications. So it takes care of compiling all the source code and bundling it into a jar file. It'll run your unit tests, it'll run the integration tests, it can generate documentation. We'll see all this stuff in the coming in the coming weeks. But I think what you need to know right now is that this is how you build your projects, is you use something called Maven. And so then, we need to, we ran the we ran the create project 0.sh script to create the project. Now we're in the directory. We need to make the, we need to make the script executable. And so we do that by saying chmod-x maven w. And by the way, these instructions are specific to a Unix environment. If you're running on Windows, there is a maven.cmd. There's also a create project 0.cmd. I think that one you need to put your login ID, which in my case would have been Whitlock, on it. So to get that student directory. And again, if anybody's playing along at home and if you're encountering problems, let me know. But now here we are in the student directory, and now we're going to build our project for the first time. And we do that by saying maven w verify. And what this does is it runs the, oops, you need a dot there. What this does is it invokes the Maven build process, downloads a little bit of stuff first, and it invokes the build process. And I guess what I didn't cover, and we can see this in GitHub. Actually, no, I haven't committed it yet. When we created the project, it created source code, it created test code, it builds all of that, it runs all the tests to make sure that everything can be built from Maven. This takes a little while, and actually, if you're doing it at home, you'll see that it downloads all sorts of stuff from the internet, all the dependencies that you have. And this is a really great thing, right? So in this course, you're going to be seeing lots of third-party software. You're going to be seeing the JUnit framework for writing unit tests. You're going to be seeing Hamcrest for fancy assertions. You're going to be using code that came from me that are all published in what's called a Maven repository. This is where all the library code lives, and Maven takes care of downloading all of that for you. So it went through, it did a bunch of things. We'll see this more in detail later. I don't know why it's having all those warnings. It's not hurting anything, but it runs your unit tests, it runs your integration tests, and it was successful. Yay! So now I've got a fully built Java project. And I think the next thing after it's successfully run is I want to put this code into my Maven repository. So I've got something that's working. This is great. I want to commit it into my Maven repository and then start making changes to it and start working with it. So the first thing I'm going to do is I'm going to clean the environment, which basically gets rid of all of the projects that shouldn't be put in version control. These are all the built artifacts. You only want your source control in your you only want your source code in your GitHub repository. So let's clean that out. Doesn't delete any source code, just deletes all the artifacts that are built or derived from the source code. And now we'll go up a directory. We will add the entire student directory to Git. Now, if we do a Git status, you'll see that there's all sorts of stuff that gets committed to the repository, and all that's what is expected. Oh, we've also modified the top level pom.xml, and so we'll add that also. And now we'll commit the changes that we've made. That commits them to the local repository. Now we'll push them up to GitHub. And we'll see if we go to our repository and reload. Yep, we just added the source files for the student project, and here they are in our repository. Just for the sake of demonstration, I'm going to then do a git pull on my checkout on the PSU machines. It will now move those files that I just pushed up to the repository over here. I can now go into the student directory, run my same maven w command, maven w verify, and this will build the project on the PSU machine. It's downloading all sorts of third-party libraries it didn't have already in my local Maven cache. That's nice. And what I'm demonstrating to you is that you can use the same tools and the same commands both on your development machine and on the PSU machine. And that's one of the things about Java, is that it's platform independent, and it has all these tools. We have tried to make it very easy for you to work on your local machine in the environment that you're used to, and then move your code over to the PSU machine using GitHub, so you're not worried about like copying files multiple times or missing a file. Whatever's in your GitHub repository is going to end up on the PSU machine, and you can run the same commands to verify it. And this is what you want to do, obviously, before you submit it, because I'm going to test your code on the PSU machine. Okay, well, that's cool. So I've been running stuff from the command line. The command line is really nice. However, it's not so great for developing. Hey, if you are like a wizard in VI, or like you've been using Emacs since you were 4, yeah, you can go ahead and do that. But there are better tools for you to work with. And the tool that I like to use when it comes to building Java applications is a tool called IntelliJ. It's an integrated development environment, an IDE that that is, even though it's commercial, it's free to students. And I think it's fair to say that it is the leading leading development environment for Java. So I'm going to launch IntelliJ. There's instructions here on how to install it and where to get it and everything like that. I'm not going to show all of that here. So I'm going to launch IntelliJ. Here it goes. It's taking a minute. Computer's probably working pretty hard. And I am going to open a new file. And the file that I'm going to open, oops, there we go, is going to be in PSU winter 2022. And it's a thing called pom.xml. Now, pom.xml is the project object model, which is the description of the Maven project. If you watch the Maven lecture, you'll learn all about it and what it means. And there's some of the stuff that's probably relevant to you. But for right now, for the first night, all you need to know is that if you open this, you're going to see your project that's there in your GitHub repository, opened up in IntelliJ. You want to say open it as project. And IntelliJ knows all about Maven. And so what IntelliJ does is it analyzes this pom.xml file and configures itself to work with the projects here in in this Maven project. Work with the code here in this Maven project. You open up IntelliJ and it gives you these nice tips of the day, which is really great when you're learning how to use it. I remember when I for the first few months that I worked with IntelliJ, these were very, very helpful to me. So you can learn all about some of the keyboard shortcuts and just some of the features of it. It's a really, really nice tool. I'm a big fan of IntelliJ. So what it's showing you over here on the left is lets you navigate the project, and so you can do that here. So you can see here you've got all the scripts and stuff. We're not going to run these from IntelliJ, but here's your student project, and so you can look through the source code for the student project, and here's your main class student. Let's talk a little bit about the student project then. So the actually I guess it was up here someplace, wasn't it? Yeah, project 0. So this is also available on the website right here under the Project Zero. This is a little Java project that originally was actually the first project in the class, but it turned out that it wasn't super helpful to have people actually implement this and then try to submit it. But basically, it gives you experience working with one of my classes, because the student class extends the class that I wrote, not one that you wrote. And it gives you a little bit of experience learning about inheritance and virtual methods and things like that. So I'm going to look briefly at what this class is all about. Actually, I don't need to do that here. I can just do that in IntelliJ. A student, we'll look at the class in IntelliJ, but what I want to point out is that the student object, the student class has a main method. So a main method is just like a main method in C. It's like when you run a program from the command line, that's where the program starts executing, is in the main method. And when you run it with these arguments, so Dave Mail 3.64, algorithms, operating systems in Java, it should print out the following. Say Dave has a GPA of 3.64, is taking 3 classes, algorithms, operating systems in Java. He says this class is too much work. That's what the program does. It's fairly simple, but we're going to use it as an example of working in IntelliJ, doing a little bit of test-driven development, and working with some Java classes. And so how does it do that? Well, there's this framework for the class here. So you have a class it's called student, and it extends human. So as you'll remember, the extends keyword is how you subclass superclass in Java. It has a constructor, right? The constructor is the code that's invoked when an object is instantiated, or rather when a class is instantiated into a new object. And by the way, if you're a little maybe hazy on object-oriented programming and how all this stuff works in Java, there are some refresher. There is a let's see here. There's a refresher set of slides here. I also have like some super old podcasts from like a million years ago. But mostly you all will remember this stuff pretty quickly. There is a says method, and all students say this class is too much work. And then there's a toString method that does the work of generating, this text right here. And there's a main method. And what the main method does is it parses the information on the command line. And here again, according to this, the first argument is the name of the student, the gender, the GPA, and the classes that they take. So it parses all of that information and creates an instance of a class with that information, and then prints the value of calling its toString method to standard out. Fairly straightforward class overall, and I'm going to be using this week and next week to demonstrate some features of IntelliJ and to learn about test-driven development. Before we dive into that, though, I did want to pause for any questions that people have about what you've seen so far. Either the GitHub stuff that we saw to get started, or the some of the stuff in IntelliJ. Yes. Oh, you saw a caret and a C go by. That was probably me hitting Control C. So like I started doing something and then I typed Control C. Maybe I did it over here. Yeah, like that. Control C is cancel the current command. Sorry. Old school Unix guy using all sorts of keyboard shortcuts and stuff like that. But thank you for asking. That's a great way to learn. I use keyboard shortcuts a lot. Sorry, it's just sort of second nature to me. When I do keyboard shortcuts in IntelliJ, luckily I've got this little thing that pops up down here to tell you what it is that I'm doing. So hopefully that will help a little bit there. But like navigating and things like that. But yes, so like I used Control C to cancel that. I can use Control R to search in the history and stuff like that. So yep, sorry. But when you see me doing something like this, and you're like, "What the heck did you just do?" Please, pause and ask. So that's what the caret C means. Excellent, thanks. Any other questions about what we've just seen? Okay. We're going to watch a video, and then we're going to talk about it for a little bit, and then we're going to take a break. Okay, video time. So I am, okay, sorry, we're going to do a technology check first. I am going to put some nice chill music going on in the background. And I am going to see if I can do that Zoom magic again so that people can hear. Oops. Nope, do I need to do this? And then, oh darn, how did I do that before? So let's see here. I think, can people on the call hear the music? I don't think you can. Or can you? No, okay. So let's see here. I want to say, oh, maybe I need to do share. How about now? There it is. Oh, yeah. Okay, good. Okay, so what you're hearing the speaker, everybody can hear it here. I don't know if I can hear people talking on the speaker. Anyway, enough of this chill out lounge music. Try to find something that wouldn't be offensive. And now we're going to watch a video about test-driven development. Now, anybody heard of test-driven development before? TDD? Yeah, a couple nods, a little bit like that. Anybody ever done it before? Oh, a couple people. Good, good, good. So you've seen it in class or at work or something like that, freshly. Excellent. Good, good, good. I am a big fan of test-driven development. I can't imagine I ever wrote code any other way, and I'll talk about why after we watch the video. This is an excerpt from a video series that Bob Martin, Uncle Bob Martin, did all about test-driven development. And even though it's cheesy in places, I find that it's a good explanation of what TDD is all about. Let's move that around here someplace. We'll watch it. It goes for a couple of minutes, like a 5.5 minute video, and then we'll talk a little bit about what it is that we saw. Well, folks on the phone, please speak up.
It's time for the red-green refactor cycle, and I am in the red phase. I must write a failing unit test. All right, what test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. Epicotting indeed. Admittedly cheesy, but what were some of the things that you observed? So I'd like to, just do a little debrief on what we saw, talk about it. So if you're on Zoom, please raise your hand to indicate that there's something to contribute, but I'd like to give people in the classroom first an opportunity to share your observations. What are some of the things that stood out to you about what Uncle Bob did in that video? Everything was really simple. What were some of the things that were simple? The test, very simple, right? Only a couple of lines of code. And you saw that as he wrote his test, he also wrote the code that he was testing, right? He wrote the test first, the test-driven development. That's why it's called TDD. Other observations. I'm looking at people on the Zoom. Raise your hand if there's something that you noticed that you thought was interesting or maybe something you have a question about. Anything that offended your sensibilities. What was that hat all about? What's the deal with the hat? Right, the hat had 3 different colors. What were the colors? Red, green, blue, and blue was refactor, right? So there's this phase. There is this structure to your thinking in test-driven development, where the first thing you do is you want to write a test that fails. This is really important. It fails because it's not implemented yet, right? That's the whole idea of test-driven development. You write the test before you write the code that is under test. So you come up with, it's like, okay, hey, what do I expect my program to do? Okay, and so you focus on one little piece of your program, on a unit of your program, like a particular method in a class. And you say, okay, this is what I want to test. So I expect, hey, listen, given these inputs in this state, I expect that when I call this method, when I perform this operation, then I will get some expected output. And that's what you do in a test. You follow this given, when, then cycle, where you say, hey, listen, I'm going to like set up some stuff. I'm going to perform some experiment. I'm going to do something, and I expect that thing that I do, that operation that I perform, to have a certain result. Now, when it's not implemented, it shouldn't pass, right? It's like, oh no, I set up something, I did something, and something unexpected happened. It blew up in some way. It returned the wrong value. Like we saw there, like when he wrote that score function, initially it returned -1 because, well, it doesn't do anything yet. And they changed to 0, and then it passed. And if you'd see, he would go on, and then he would run, he would bowl something other than a gutter game. Initially, the score would always return 0, and then he'd have to implement the ability to compute the correct score. This is that red. Oh, and then so he was first. It was red. Then he would change the code to make it. They change the code under test to not the test itself, the code that's being tested, to make it pass. That's the green. And then he goes to the refactor stage. Now, has anybody heard of refactoring before? What are some when you hear the word refactoring? What do you think? How would you describe refactoring to somebody who doesn't know what it is? Redoing the code? I don't know if redoing is exactly the right word. Sometimes it means, re-implementing it or making big changes. But more often, it means making small changes. So like renaming a method to make it easier to read and understand, or to, you saw him removing duplicate code. Sometimes you do that, right? Write the same code in 2 places. You're like, wait a second, let's write that in one place, put it into its own method, into its own function, and call it in multiple places. And that's what you do. And the thing I like about test-driven development is that you work very incrementally. And along the way, as you're working in these small increments, you write more and more tests. And what the tests give you is confidence that, yes, what you have implemented is actually doing what you think it does. Now, this might seem simple. And I remember that earlier in my career, I'm like, come on, I did the right thing, right? And I thought about it. I was like, well, right? Didn't I? How do I know? And then as I got further, as I wrote more and more code, I'm like, wow. When I break things, and it's often subtle, and you don't realize they can make a change over here, and maybe it breaks something else. And the longer you wait to find out that you broke something that used to work, the more harder it is to fix it. So, I'll harp on this a lot during the class, but for me, test-driven development gives me a lot of confidence that the right things are happening, and it gives me, and when I have that confidence, I can go faster. So I'm going to change back to the headset now and do that. So I think the Zoom stuff's going to go in my ear instead of on the speakers. Anyway, so that is a very brief introduction to test-driven development. We're going to see a little bit more of it after the break, though. Let's take a 10-minute break, 11-minute break, 11 minutes. Let's return back again at 7:30. Zoom recording. Okay, we're back. So far in class, 2 hours, they just fly by, right? We've learned about the class. We have looked at the Getting Started repository for creating a Git environment in which we can do our projects, and we used the Maven W wrapper class wrapper script to run Maven and to build our first Java project. And we just saw a video all about test-driven development. I think what I'd like to do now is explore IntelliJ a little bit more with all of you. And we'll do that for a few minutes. We will write a couple of simple unit tests, but I do remember that I wanted to have you all work together to help me to convey your experiences working remotely and working hybrid like this. And so then we'll set aside some time to do that then, to do that also tonight. And then we'll finish off class by talking about Project 1 and the Java Koans. So still a ways to go. Realistically, it'll probably be close to another 2 hours. I'll try to go to at a decent clip, because quite frankly, I'm getting a little tired, and as I'm sure some of you are also. And so let's make sure to stay on task and get some good work done. Okay, excellent. So let's go back to IntelliJ. So let's take another tour of IntelliJ. Over here on the left, we can basically browse the file system. And so we can look at the student class. You've got that right here. And over here in the test directory, we have our unit tests. And these are just like the tests that Uncle Bob was using in that video. I will say that video is kind of old, and so things look a little different now in terms of IntelliJ and also in terms of JUnit. There is a relatively new version of JUnit, JUnit 5, which adds some nice things. It's all covered in the lectures, and that's what we'll be using in this course. So this right here that we're looking at is a what's called a unit test. Now, a unit test focuses just on one unit of code, like a method. And what I'm going to do here, I'm going to go into split screen mode. So I'm going to say I'm going to take this. Actually, I'm going to say take the student test. I'm going to say split and let's see here. Split right. Oh, I don't need it in both places. So over here on the right, I'm going to close that list there. Over here on the right, I have my test, and then over here on the left, I have my student class, which is the code that is under test. My first test here that came out of the box is called student named Pat is named Pat. And so what I'm going to do is I'm going to create a student object whose name is Pat, and then I'm going to assert that when I call the getName method on the Pat object, that the value of this is equal to my name variable, which is the string Pat. Now, this method call right here, assert that and equal to, are part of an API. Are part of an API called Hamcrest, which is an anagram for matcher. It's covered in the lecture notes. This is another library. It's an open source library that works with JUnit that allows you to have much more fluent assertion statements. As you'll see in the lecture notes, you can do things like compare. You can assert that a value is greater than a certain number, that a string contains a certain substring, all sorts of great stuff like that. It's really nice. It takes a little bit of getting used to, though, and so we'll see examples of it here, and of course, it's described in the JUnit lecture also. So here I have this test. By the way, the test is just Java code, right? There's really nothing special here. It's Java code that uses special Java APIs like that assert method, and then also this @test annotation. This is a part of the JUnit API that denotes that this is a method that is a test, is a unit test. And IntelliJ looks at this class and it knows some things about it. So for instance, it knows that it has a test method. And so then it gives you this option over here in the gutter to run that particular test method. So when you click on that, you get this menu. You can run it, you can debug it, you can use code coverage on it, all sorts of great stuff like that. We're just going to plain old run it. So we'll click on run there. And when we do that, IntelliJ will build the project. Oops, it will build the project. Oh yeah, there it is. Down there at the bottom here, it's building the project right there. I guess you can click on it and see it was doing some stuff and then it finished. Now it's going to run the unit test. And it tells you, okay, here's the test that I ran. It's the student named Pat method in the student test. And here are the results. Everything passed. It said test pass, 1 of 1 passed. So this is what Uncle Bob was doing. He was, he wrote a test and then he ran it. Now, when I run the test, I like to use the keyboard shortcuts. For me, I have the keyboard shortcut to be configured on my machine to Control Shift F10, of course. On Windows, can also be Control Shift Control Shift R, and that runs it. So this is my first test. So I'm going to create a student object with the name of Pat. If we go and look at the constructor, we can bring it up over here, or what you can do is you can click on the student constructor and you can right click to say find usages. Actually, sorry, no, I don't want to find usages. I want to get declaration. So I want to say go to declaration or usages, and that'll bring the cursor over here in IntelliJ to the declaration of the constructor. The keyboard shortcut for that is Command B to bring you over there. And same thing with the get name. If I say Command B, it'll, oh, actually that method is inherited from the superclass, and so it actually brings you to the source code of the superclass, which is super nice of it. Thank you very much, IntelliJ. So over here we can see that the constructor for student calls the inherited superconstructor from the human class and sends it the name. And then we can go and navigate to the superconstructor. You can also do it by holding down Command and clicking on human. That will take you to the source code here. And then you can look even further up for animal, which ultimately has the name method. Sorry, the get name method. So this is the nice thing about IntelliJ, right? It lets you navigate your source code, it lets you see all sorts of things very, very easily. Now, thinking about my student class, I want to write another test. So I want to think, and I want to follow Uncle Bob's advice and think of like something very simple. Can anybody, either here in the classroom or dialing in remotely, can think of a simple test case that we would want to run this student class through? Oh, okay. Suggestion was make the name really long. Great. How long is too long? Oh, yeah, 40 characters. Great. And so, this is what you do when you're testing, right? You explore what are the boundaries of your code. So, like, what do you expect? Now, as it turns out, we didn't really put an upper limit on the name of the student, but let's do that. Let's implement that. So let's assume that we do that. Now, this is always kind of an interesting conundrum because it's like, well, is it reasonable to have an upper limit on the name? It probably is. So let's do that. So what we're going to do is we're going to write a test method, and we're going to call it, let's see here, a name longer than 40 characters. What happens? What should we expect to happen if we try to create a student with a name that's longer than 40 characters? Well, in Java, when things don't go right, what happens? An exception is thrown, right? Did y'all remember what exceptions are? So let's say you do something like try to reference an object that's null, or you try to index an array with a negative index value, you get an exception. And so this is, in Java, this is how you convey that something's gone wrong. So you can say, okay, let's say that we'll say if a name is longer than 40 characters, throws illegal argument exception. Oops, you can spell things out. Thank you, IntelliJ. It tells me that argument is misspelled. That's very helpful. Okay. Nice. Okay. So let's see here. String, we'll just call it too long name. Equals 40 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10, 20, 30, 40. Okay. Now, okay, so if we so we want to create a new student, and with too long name, and we'll make a new array list, and we'll talk about what that is in a little bit. We'll have a GPA of 0, and then the gender doesn't matter. Okay. Now, this should throw an exception. So we'll do the following. So we'll say that, listen, that we expect to throw an exception. So we will wrap this in a try-catch block. Oops. And so, right, catching an exception. So, like when an exception is thrown by some code, the calling code can catch it and then do something with it. So it'll be an illegal argument exception. And here everything passes. But if this constructor is called without throwing that exception, we'll call the fail method. And this is the fail method from JUnit. Assertions.fail with should have thrown an illegal argument exception. Okay. Well, if I were to run this test right now, what do we think would happen? It wouldn't pass. Why wouldn't it pass? It would? I don't know. Let's try it. And this is a great thing, right? It's like you can speculate or you can just run the test. So let's run the test. It compiled and it said, assertion failed, error should have thrown a legal argument exception. So I can click on the stack trace right here and it brings me right to the line where fail was called because it's true. Even though we sent the too long name to the constructor, our code over here doesn't check anything about the name. So that's what we need to add. We need to add a check over here. This is okay, right? This is red, green refactor. So it's red right now. The test is failing. That is a good thing. That means that we are exercising our code in a way that's not yet implemented. This is perfectly fine. This is exactly what you want. So, okay, so what can we do? We can say, okay, if name.length is greater than, what do we say, 40? Oh, wait a second. This is exactly 40 characters. So we want 41 characters. If it's greater than 40, then we want to throw a new illegal argument exception. Name is too long. Okay. Now let's run our test again. Hey, it passed. Because now, when the student constructor was invoked, the name that was too long, it did throw an exception. But you know what? Maybe I don't believe that. So now we're going to see what it's like to debug something. And I'm going to talk more about, actually, I wrote up a nice thing about debug. I don't know how nice. I wrote up something about debugging in the Getting Started repository, but we're going to see it here. I'm just going to walk through it and we can go into details at another time. So now I'm going to rerun the test, but I'm going to say, instead of saying run, I'm going to say debug. Now, so when you run something under debugger, you can set something called a breakpoint, and that's why I clicked over here in the gutter. And this says, hey, run the code until you hit one of these breakpoints and then stop. And then you can inspect what's going on. So it's basically the program is in the middle of running, the test is in the middle of running, and it's stopped here at the breakpoint. Maybe this is too advanced for the first day. Maybe I'll cover more of this later. But what you can do in IntelliJ is that you can then step into the code. So here I am in my test code. I'm about to call the new student constructor. And I can use these commands here to say step into. So what I'm going to do is step into the, and I want to step into the student constructor. And now the code is over here. It's invoking super, and the value of name is this big old string right here that we passed in over in the test. And now we can say step over. Oops, where is it? Step here. Step over to go to the next line. And it's going to then compare name.length. We can look over here and say, here's name. We can and say, is it greater than 40? It even tells you it's going to evaluate to true. And so then a new illegal argument exception is thrown, which is then caught, and then things go on. And so we can just say continue. Anyway, we'll see more about debugging later, but that's one of the things you can do in IntelliJ. You can set these breakpoints to stop in the debugger, because like when things don't go wrong, it's really great to use the debugger to inspect what's going on. So we had a red test. We made it green. Now can we refactor it? Anybody see an opportunity for refactoring? And sorry, you know what? I don't see anybody's hand raised at home. Nope. I see an opportunity. Anybody else? Just like with Uncle Bob, when he went and created that field for the game, I'm seeing we're invoking like the constructor the same way, and the only difference is the name. And I think it'd be a good idea to basically take this code and say, hey, I want to have a method that just takes a name and returns a student. So I am going to highlight that code and then use the refactoring menu here to say extract method. And let's see here. It says, oh, I'm going to create you a method called getStudent with a name. And I'm going to change that to be, oops. I created that method. I don't want it to be called that. I'm going to refactor it again to change the name. Rename. And I'm going to call it, oops, what the heck did I just do? Sorry, let's try that again. Take that code. I'm going to say refactor. I'm going to say extract method. And, oh, there it goes. Sure, that's good. And it tells me, oh, wait, we found another set of code that looks just like that. Do you want to replace that occurrence with the new method too? Yes, I do. And so now both of these call the getStudent method with the name, whether it's the pat name or the too long name. Now I don't like that method. I don't like the name getStudent. I'm going to change the name of it by saying refactor rename, and I'm going to call it create student with name, or create student named. Oh, and you know what? For this method here, I don't want this to be too long name. I want that just to be student name. You see what I did though? Like IntelliJ was smart enough to like rename all of the occurrences of it, so your code still compiles. You try to do this in VI, it's not so easy. These are the nice things that IntelliJ gives you. So I just did some refactoring, and now when I run it, let's run it under the regular. Sorry, I'll run it. I'll run my tests again. Actually, I want to run all of my tests in my class because I changed both of the tests. So I'll run that again. So it needs to rebuild everything, and then I'll rerun it, and both of my tests pass. Good. This is a safe refactoring. So again, that red-green refactor. Just as, you know, so I wrote a test. I wrote some code for it. Everything's working. Now I'm going to. I made some changes to my source code. I want to commit them to Git and publish it to GitHub. And so I can do that in IntelliJ also. So if you have Git configured, it gives you this little Git menu down here, and it says, hey, you have made changes to 2 files, to student test. You can view those changes over here on the right. It gives you a nice little summary of them. And say, great, I like those changes. All my tests passed, and I want to commit them. And so you can use IntelliJ to do Git stuff, to like commit your files. So I'm going to commit those, and I'm going to say added my first unit test. You know, the best commit message, but who cares? And you're going to click the commit. Actually, you've got a choice. You can say commit or commit and push. Well, I'm going to commit to my local repository. I'll push it off to GitHub. Sure, what the heck. So you can do that. It committed it to the local repository, and then it's giving you a confirmation dialog. Say, yes, you really want to push these changes up to GitHub. Yes, I do. What are my options? No, I don't want force push. Just want to push it. So yeah, I'll get to that in a moment. So you can see there's no more local changes because they've been because the local changes were committed, and we pushed them up. The question was there between push and force push? You know, I'm not. Shoot, I have to go look it up. I don't know if force push, would it ignore any conflicts, right? So the whole idea is that you know, as you're pushing stuff between repositories, you can have different clones push. So basically, you know, the clone on my right hand can push changes to the central repository, the shared repository, that maybe the clone in my left hand doesn't have. And so force push, and again, you can Google it as easily as I can. It might usually what happens is that the push will fail if there are changes that haven't been pulled or merged down into the other repository. Force might override that. But in general, you don't want to force things, right? And actually, I just want to say a couple words here about Git. Git is great. It helps you move code across. You learn about version control and stuff. But boy, I have seen students really mess themselves up by trying to be too clever with Git. So if you find yourself, I'm going to rebrace my branch, or I'm going to force push, take it easy, right? Use the simple stuff in Git. It'll serve you very well. And if you find yourself having to go through some really kind of weird contortions or whatever, or if you're 3 deep in Stack Overflow articles to figure out how to reset your head or pointer or whatever like that, you might have gone too far. Reach out for some help, because while Git has your whole revision history, it doesn't mean that you can't do something that'll inadvertently lose your lose history or lose recent changes and stuff. So try to stick to my advice to you is try to stick to the simple stuff while you get experience with Git, and then hey, when you need it, you'll be familiar enough with the underlying concepts so you can use branching, so that you can use rebasing, you can do all that kind of stuff, but maybe not on your first day. So I made some changes to my source code. I committed them to my local GitHub repository, and then let me check. I believe now they should be available in GitHub. Nice. There they are, my first unit test. And actually, let me just go back to the command line here. I am going to go back to my student directory. I'm going to run my Maven verify command, which will run those same unit tests from the command line now, just to make sure everything works. And actually, if we go and look, we'll see our student test now contains 2 tests that were run. That's neat. It's going off and now running the integration test. We'll talk about those next week. It was successful over there. Over here on my PSU machine, I'm going to do a git pull to get the recent changes. It says, oh, yeah, your student class has changed, your student test class has changed. And now I can run my Maven verify. As a matter of fact, I probably want to do a Maven clean verify, which will first delete all the code that was, delete all the binaries that were built, and then rebuild everything from scratch. So this is just me demonstrating that through GitHub and Maven, you can verify that your code works still from the command line with only a handful of easy steps. But you'll probably spend the vast majority of your time working in IntelliJ. So that was a simple unit test. There's a lot more TDD that we could be doing, but I want to do something else now. I want to hear from you. So let me see here. What's the best way for us to collaborate? Okay. Here's what I'm going to do. I want to try out. I want to try out some breakout rooms on Zoom just to make sure it works. But here's what I'd like you all to do. Like I said at the very beginning of class, we're in unusual circumstances. And I've never done the hybrid thing before, and I've done remote, and got a little bit of experience doing that. But this feels so different, right? I'm here on campus. There's 6 people here in the classroom. There's a whole bunch of people on Zoom, who, by the way, haven't been raising your hands. So I don't, I'd like you all to participate in class. I'm trying to figure out how to do that. And so what I'm going to do now is let's go into breakout rooms for 15 minutes. And here in class, again, I want you all to be comfortable. And so if you'd rather join a Zoom breakout room, you're welcome to do that. If you want to work with other people around you, do that too. Be safe, figure out what works for you. And what I'd like you to do is very, very shortly, what I'll do, actually, how do I, what I'd like to do is have a conversation or gather information about things that have not been effective for you, in terms of working in taking classes in a hybrid environment. So what I'm going to do is I am going to I'll just create a new document. Come on, wake up. Google Doc. I'll just create a new Google Doc. And I will make everybody in the world a collaborator on it. And I will share it here in chat. I'll also put it on Slack. Maybe I don't know how best to get it to you all. Maybe I'll just take notes for you. And we'll call this experiences in remote/hybrid learning. And I'd like you to brainstorm. Let's see here. Anyone with the link? Anyone with a link and edit. And so what I'd like you to do is let's see here. Can we just make a table? Let's just make a big table. Insert table. Insert table with 3 columns, lots of rows. And then what has worked well in hybrid learning, what hasn't worked well, and then ideas for this term. So what I'm going to do now is I'm going to send people in Zoom off to some break. Actually, first of all, sorry, I got to share this. Here's the, oops, here's the document for collaborating. That is not the document for collaborating. Share, copy link. If people who are on the Zoom could pop onto that document and make sure that you can edit it. Let's time, excellent, Anonymous Badger. I'll send you all into breakout rooms, and then what I'd like you to do is collaborate virtually on answering these questions, capturing things that have worked well for you, haven't worked well, and any ideas that you have for this term. Here in class, I'd like you to do the same. Talk with some other people. If you've got access to the document, great. Otherwise, just write some notes or do your own document or whatever, and we can talk about that during class. Does that make sense? We'll do that for 15 minutes and come back for another 15 minutes or debriefing and talking about what worked well. I'm generally interested in hearing about your experiences doing this so that I can avoid the things that don't work well. I can amplify things that do work well, and then maybe try some new stuff based on what your experiences are. Okay, so let's go to the breakout rooms. Let's see here. I'm going to let you all choose a room. And I'm going to create, how many people we have online? We have 18. So let's create 4 breakout rooms. That's like 4 or 5 people per. Yeah. Okay. Rooms are open. So please feel free to self-assign yourself to a room. You can do that with the breakout rooms. I believe there's people have a breakout rooms thing. Otherwise, yep, looks like people are self-selecting in. Go for it. I might also then, well, actually, probably anybody who doesn't self-assign, I'm going to assume that you are not participating in this. But go for it. Okay. And then meanwhile, people here, feel free to get together and to talk about what's worked well, what hasn't worked well, and any ideas that you have for this term. I'm going to pause the recording for a few moments, and we'll reconvene at 8:15.
Before the pandemic.
Speaking of recording, sorry. Cool. What were some? You had mentioned that there were some techniques that you found to be effective for communicating. What are some of the tools that have worked well for you, or what are some of the tips and tricks that you would like to continue this term?
For communication or for something else?
Yes, for communication.
Oh, yeah, well, at least in I mean, I can only speak for myself, but having a microphone for people that are there in person definitely helps.
Oh, yeah.
So just so that, especially if it's one that can be like an area mic or something, where if it's like a small group of people, they can have it there. and it's like close to them. I don't know. That's
Yeah,
helped in the
that's a
past.
good idea. Okay, cool. I will think about that. Yeah, I'm trying to like reiterate things, but yeah, it's something like hearing your own voice. And speaking of which, Eric, thanks for coming off mute. And see, you must have a really nice microphone because you sound great over the speaker here in the class. So
Thank you. I do have a podcasting mic that I got on
yeah,
sale. So woo.
right on. Cool, thanks. Anybody else from group 2 would like to share their experiences? Yeah. Room 3, which was Parth and Jacob. Anything that you would like to share? If so, please feel free to come off mute and tell everyone about it. They were pretty quiet when I was in their room. That's okay. It's the first day. We'll warn you though, later on in the term, we'll all get experience working in breakout rooms or here in person with other people. But for tonight, it's okay if you don't have anything to share, because certainly you've contributed to the document. Okay, and finally, room 4, which was Amelia, Patrick, London, Mina, and Santiago. What did you find interesting in this discussion? What are some of the techniques that have worked well? What are some of the experiences you've had that maybe weren't so great? And are there any ideas that you'd like to share or suggest for how we can have a more effective hybrid experience this term in advanced Java programming?
I can talk if unless anybody else wants to.
I'm guessing they don't. Thanks, Amelia.
Okay. Something we said worked well was having recorded lectures, which it looks like a bunch of other people noted too. That's new for me and really helpful. And something that has been more of a challenge and hasn't worked as well is that it's hard. I noticed that it's hard for professors to split their attention between the classroom and the Zoom. And I actually experienced that too myself. I facilitated a lab that had Zoom participants and in-person participants. And yeah, that was a challenge. And some ideas that we had was we thought that the reactions worked well, like asking for reactions. It's like a pretty low-key way to participate, but like all kinds of prompts are good. Like when you ask the Zoom participants for questions and pause and like let us like respond, that was good. But the reactions in particular seemed like really quick. So
great,
yeah.
thanks. Good
Yeah.
deal. Yeah, I will keep that in mind. And yes, I mean, I'll echo your experience of it's hard to like keep one eye on the room and engage the 6 people here and also looking at the chat and everything like that. So bear with me. I'll try my best to figure it out. But yes, it's more plate spinning, more elephants on balloons or whatever it is. Yeah, cool. Okay. Oh, and yeah, London gave you a shout out. Okay, thanks. Great. Well, good deal. Thank you for that. I will. I'll take a look at these, and if anything else occurs to you, either more things from other classes, or just ideas that come to you, and of course any feedback, I'm more than open to it. Just to reiterate, I'm here for your benefit, and I will try my best to make sure that you can have the learning experience that you deserve and the one that best fits your needs. Okay, nice. Okay, well, let's do, what do I want to do next? Oh, let's talk about the assignments, because it's getting kind of on in the evening. Okay, so we looked at that Project Zero, which was the student project. We touched barely on it. Next week, I'll do some test-driven development. Tonight, let's do a little bit more. Let's explore the first 2 assignments. So let's look at Project 1. The quiz is due next week. Okay, so the question was, hey, when is the quiz due? Let me go back to Canvas because maybe a visual will help. Okay, so one of my sort of teaching tenets is that if it's Wednesday at 5:30, I want your attention here. I don't want you doing the assignments. All the assignments are due right before class. Okay, so the quizzes due before class, the projects due before class. There's something called a plan of attack, which we'll talk about next week. That's due on Sunday nights, but everything else, as you can see, is due on Wednesdays. So when you're planning your weeks, when you're thinking about when you need to focus on things, it all happens on Wednesday nights. So next week we have class, and then we have the programming background quiz. Let's talk about the first project. So the projects in this class, and I believe there are 6 of them, build on one another. And so this first one, all you're doing is you're designing your fundamental application classes. First blush might seem very easy, and it is, but please don't let that give you a false sense of confidence that you should wait until the last minute. Don't wait until the last minute. Get started as soon as you can. This term, we're going to be building out an airline application. Basically, what you're doing is you're managing an airline that has flights associated with it. And we'll be using these fundamental classes that you build here in Project 1 throughout the entire term to model airlines and flights in various fashions. The goal is for you to work with some of my classes, the classes you did not write, and to parse the command line in maybe a more complex way than you have before in the past. So there are some classes that I provide. And in Java there are these things called packages, which are namespaces for classes. And so there's a package called edu.pdx.cs410j, which is code that I wrote that you'll be using in your project. And there are 2 abstract classes in that package called Abstract Airline and Abstract Flight that are the super classes for 2 classes that you're going to write in your package called Airline, that extends Abstract Airline, and Flight, that extends Abstract Flight. Abstract classes, because your classes are concrete classes, they must implement all of the abstract methods of a superclass. So just to describe these classes, and we'll see what they look like in a moment. An airline has a class that contains multiple flights. An airline has a name to it, and it also contains multiple flight objects. Flights depart from a source airport and at a given departure time, and arrive at a destination at a given arrival time. And so these are the objects that you're modeling. Note that for this assignment, though, you can model all of the details about the flight, such as the departure time and the source airport as just a string. We'll learn about using other classes for representing dates later. If you know how to do that now, it's fine, you can, but for Project 1, strings are the most easiest thing to do. Every flight also has a number, which is represented as an int, the primitive int. There are 2 methods called getDeparture and getArrival that are inherited from abstract flight. You can ignore those for this assignment. We'll look at them in a future assignment. Oh, I guess I have some duplicate information there about the identifying number. In addition to those classes, there's also a class called Project 1, which has the main method. So again, the main method is where the program starts executing, and what your main method will do is parse the command line, and we'll look at the command line format in a moment. It'll create an airline object in a flight that's described on the command line as the flight to the airline, and if there is a -print option, then it'll print the flight. And that's all it does. So just to be clear, this Project 1 doesn't do much of anything. It creates some objects and maybe prints something out. Nothing's written to a file. Nothing persists between the invocation of the program. Don't worry, we'll get to that in Project 2. Right now, the goal of Project 1 is just to write a little bit of Java code, parse the command line, write some tests for it, good stuff like that. So here's what your command line should look like. Your program should take some optional options followed by the required arguments. The arguments are as follows. The first argument is the airline, followed by the flight number, the 3-letter source code for the departure airport, the departure time in 24-hour time, and here is an example of what the departure time looks like. And then there's the 3-letter code of the arrival airport, the destination airport, and then the time at when it arrives. There are two options. There's the -print option that if this appears as an option on the command line, then the description of the new flight should be printed by invoking the toString method. There's also something called a -readme. We'll cover that in detail next time, but that can be on the command line options also. So that's what the command line looks like. We'll get some more detail about this shortly. There's a couple, actually, there's a lot of notes here in the footnotes, including something called the POA, which again we'll talk about next time. And if you want to look at that, you can. If you want, but if you want to find out now, you can read the how to document your code handout from next week. But let's see here. Oh, note that the dates and times here. So for depart and arrive, those are two command line arguments. They should not be in double quotes. And then a bunch of stuff that's kind of what I've already mentioned. You can use the date class now if you want. The only way that the user provides input to the program is from the command line arguments. I know we all learned in CS 101 how to read from standard input. That's an assignment. Please do not read from standard input. Every term one person does that and messes up my grading scripts. And it's just kind of mind-boggling. So big bold letters, do not read from a file, do not read from standard input, just only take things from the command line that are passed in the args array to the main method. Note that the year is always 4 digits, even though the day and month can be 1 or 2 digits. Now, again, this program doesn't do very much. And so how am I going to test your program? Well, it's mainly about error handling with the input on the command line. So please make sure that your program exits gracefully. So don't throw an exception. Don't print nothing or whatever. Exit gracefully with a user-friendly error message under all reasonable error conditions. Now, I'm not going to specify every error condition, but some examples of that are, hey, your command line is incomplete, or maybe there's extra stuff on the command line, or the format of the day and time is wrong. The flight is non-numeric. Airport codes don't have 3 letters. Things like that. If you have a question about what is and is not valid input, please feel free to ask it. I will tell you yes, no, but I'm not going to give you every single valid or invalid command line. That's part of what the assignment is figuring out how to handle various exceptional inputs. Note that when no command line arguments are provided, the program should provide a helpful message that explains how the program is used. So if there's nothing on the command line, please print out a little bit of information. I will go over submitting all of this stuff next time. But before I go into more details about this, any questions about the basic requirements of the project? And I'm looking for hands on Zoom or in class. Susan, yes, in class. Question is, what is the README? We'll talk about that next week. There is if you want to read ahead, there is a documenting your code for CS410J handout, which is in next week's how to document your projects. But you don't need to worry about that for now. Focus on other things for now, like just getting started. Oh, and by the way, one important thing I did not cover is that this project is due 2 weeks from tonight on January 19th. Let's see here. Other questions? No hands raised in Zoom. Nothing wrong with that, but okay. Okay, so those are the expectations for the assignment. That is the details of the assignment. Let's look at how to create the code. I've got a whole bunch of text here in the assignment, but I'm just going to explain to you here. So if we go back to our repository, our checkout, there is a script called create project 1. I'm going to change the beeps here. There we go. Create project run. If you run this, it will create, just like it created the student project with create project 0, it'll create your airline project. And by the way, you have to have run the survey program first so it can find the me.xml. Okay, and now if we look, we now have an airline directory. So let's go into that airline directory. Let's do the same thing, and this is just like with the student program. We need to chmod plus x the Maven W, and then we can run Maven verify, and this will build everything. So again, this project, just like the student project, also uses Maven to build. And so it'll compile the source code, it'll run the unit tests, it'll build the jar file. And I'll explain short what the jar file is as soon as it's ready. And I'll run the integration tests and then be ready to go. Nice. Actually, I'll give you another minute on the jar file because I want to get this code into GitHub first. So if I do a git status, so that there is, let's see here. So the current directory has been modified, as is the pom.xml, the top level pom.xml. So I will say git add airline. And now if I do a git status, we've got a whole bunch more files, some of which we'll look at tonight, for the airline project. And then, we'll also add the pom.xml. And I'll explain more about the top level pom.xml next week. And so now we'll commit these to GitHub added files for project 1. For the airline project. The airline project. Oops. Great, and I'll push this up to GitHub. Oh, and by the way, and here I just love the whole Git push thing. It's like I can see it on the internet. I don't know. All these years later, I'm still impressed by all this stuff. If you're looking for my repository, here's my repository. If you want to follow along, and by the way, feel free to use stuff. I'm not going to implement the project here, but feel free to consult. That's why I make it public so that you can see it. Yours, however, should be private. Okay. Now that I've done that, I'm going to go back to IntelliJ, and I am going to click this refresh, which will sync the file system with those changes that we just added. Also, it detects now that I have an airline project in my repository. And so let's take a look at the. It creates some files out of the box for you. So actually, let me close. I'm just going to close everything over here. We'll open this up later. Close all tabs and group. Let's see here. I'm going to hide those controls in Zoom. Sorry, wait a second. It's super annoying. There we go. So go away. Come on. There we go. Okay, so I don't need to see me anymore. So here is the. Let me make that bigger. Zoom. There we go. Here is the main method for the project 1 class. The first thing it does is it creates a new flight object just to make sure that it can be constructed. And then it prints out missing command line arguments. And here's how you invoke that program. So the Maven build, if we go back to the airline directory, the Maven build in the target directory, target is where all of the compiled and the built artifacts reside, creates a file called airline. Oh, sorry, I thought I turned that off. Why is it still coming through the speakers? So because of this, there we go. The Maven build creates a file called airline-2022.0.0, which is the version of it .jar. So a jar file is a Java archive. This contains the class files. So here again, you might have learned how Java source code is compiled into bytecode, which is class file, which is put in these .class files. And so if you look at the contents of that, it should be jar.tf. This is the contents of that, and it's got the class files for things like project 1 somewhere. There you go. So it has an entry for edu pdx cs410j whitlock project 1.class, which is the compiled output of the project 1 source code right here. It's also, there's a special jar file that has a main entry in it, and so it has the notion of a main class. And what I can do with that is I can say java-jar target airline.jar. What this does is it runs the main method, because what does it do? It prints out missing command line arguments. Now, this is a demonstration for what command line arguments are all about. It also goes through and will iterate over the arguments that are passed in to this string array, which is what's on the command line, and print them out. So if I say, hello, everyone, it prints out missing command line arguments, and then hello, and then everyone. I can have a multi-word command by putting things in double quotes on Unix. And now it has one argument, hello, everyone. So anyway, that's how the main method works. So what ultimately what your program needs to do is it needs to implement the main method that supports these command line arguments. And again, a big part of Project 1 is learning how to efficiently and effectively, how to write good code to parse the command line arguments and deal with all of the errors and things like that. If you're looking for ideas on how to do so, I've got some off in my code repository, which is the, let's see here, is this code repository right here, which is just plain old Portland State Java. Oops. Oh, I've got dependabile alerts. I should fix that. Is it log4j? Oh no, it's an old extreme. Okay. Anyway, you can look in like the examples here, or maybe the family application, and find some techniques for parsing the command line that may or may not suit your needs. So essentially, this is your Project 1 class. Out of the box, I create some files for you. For this first project, you're going to need the flight and you're going to need the airline. Airline XML helper, text helper, and text parser are for future projects, so you can ignore those for now. But you can look at your flights class. Flight extends abstract flights. It implements a bunch of methods, it overrides them, but you'll notice that they throw exceptions when you try to call them. And so part of the assignment is to implement these things implement these methods to do reasonable things. See here, airline, again, it has some methods implemented, but it also leaves things unimplemented for you to do as part of your assignment. My goal here is that I don't want you to have to write all the code from scratch on your first day. Don't worry, there's plenty for you to do. This helps get you started so that you can quickly start working with IntelliJ, start quickly working with writing code, and not be tripped up by a bunch of getting started type things. We'll talk about what resources in Javadoc are later. Note also, and this is something that we'll cover more next week, is that there are tests associated with this. So we do have like a Project 1 test. That's a bad example. How about flight test? Yeah. So it has some unit tests associated with it that you'll have to implement. Note that some of these tests are only there to work out of the box. As you start implementing things, then you'll delete them, right? So here's one that says, hey, listen, as the way the code works right now, if I try to invoke the getArrival string method on a flight, it'll throw an unsupported operation exception, which is exactly what you'd expect given how it's implemented right now. But as a final implementation, you'll want to have it return the arrival string. So let's see here. I think that's probably enough on this. So please, go home tonight as you're going through setting up your GitHub repository. Get started with Project 1. At least create run the create Project 1 script. Get yourself some source code. Start playing with it. You can run the tests. I should probably do that. go back to the flight test, and so you can run all of the tests, make sure they pass. And they do. Cool. More stuff that we can dive into next week, including the exact expectations for test coverage and stuff like that. All good stuff, though. So that's project one. So you create it with the script that'll give you some Java code to get started with. Run it in IntelliJ. Start thinking about it over the next couple of days as you're getting started with the class and preparing things. Any questions on that, either about some of the stuff in the code that we just saw, and or questions about the project one assignment? Yep. Oh, okay. So you're having an error with creating project 0. Can you tell me what the error is? Oh, interesting. So can't find the POM. What have you tried the student class? Sorry, did you try the create project 0 again, please? Yeah, did that work for you? Oh, interesting. Okay, so somebody's having problems resolving the POM. Folks, let's see here. Has anyone got to work? It's not unheard of for things to work in my environment to not work in yours. So has anybody been playing around, playing at home, and gotten the create project 1 script to work? Could you join the Zoom so you can share your screen? That would be cool. Let's debug this in real time and see what it is. For folks at home. Yeah, non-resolvable POM. That's Oh, let's see here. You're Jacob, right? Okay, I will need to. Sorry, just give me a moment to enable you to share the screen. I always forget to do that. And sharing options. Anybody can share the screen. Okay, cool. Yeah, if you could hop on if you could just share your screen, and I'll take a look at it. Actually, you can probably, well, if you want to join the audio, you can. I don't think there's going to be any feedback because I've got all the stuff going through my headset. Yeah. Let's see. And are you on audio? Yeah. Oh, let me see if I didn't see if you were muted or not. Okay, go ahead and unmute. So you're going to hear me, but there's no feedback. Actually, you can mute. Sorry. Can you turn off your speakers, but then turn on your microphone? Yeah. You're muted on Zoom. Here, let me ask you to unmute. Okay, this says microphone's not working. Okay, well, that's cool then. We'll talk through it here. Okay, so then can you show me what happens when you run the create project 1 script? Okay. Oh, what does it say? Cannot read project, unresolvable. Current POM for. Well, why is it trying to find that? What's interesting? Do you have? Huh? Should be right there. You've got a pom.xml in that directory. Hmm. Can you less that oops, that pom.xml or VI? Oh, yeah, okay. No, that looks good. That looks good. Okay. I don't see a quick answer to that, so that's not spend any more class time. Could you please make me a collaborator on your GitHub repository and I'll check it out? Awesome. Thank you. Appreciate that. Okay, that's okay. Yeah, that's surprising. I don't quite understand what's going on there. So it sounds like at least one other person was able to get it to work, but that doesn't mean that you're not the only one that'll have that problem. So, interesting. Okay, we'll figure that out. And if it's something common or whatever, I'll try to update the README with that information. So anyway, okay, that's project one. And actually, wait, before we move on, because we've got one more assignment to talk about, are there any questions from people that are remote, that are on Zoom? Nope. All right. Project one, due in 2 weeks. Please get it started early, and just to make sure that, yeah, there isn't anything broken with my processes or surprising about your environment. The other project assigned tonight is something called the Java Koans. So, you know, the Java programming language, maybe is new to some of you. Some of you might be familiar with it, but there's probably lots of areas that you haven't explored. And so for a number of years now, I've been using these what are called koans. These are teaching questions that come from Buddhist discourse that are meant to teach you a little bit about, or rather, to teach you about little parts of the language. Like, okay, here's some interesting things that you can do with integers, and here's how like how a particular class works. Those kinds of things. And so these aren't mine. I forked the repository that this guy I think he's in Chicago, named Matt Bentley, put together. And it lets you go through and learn about the Java programming language in these little bites and little bits and pieces. So this is another project that you can create from your GitHub repository. So going up to the top here, you can run the create Koans script. And when you do that, it creates yet another project in your repository, and it'll show up in IntelliJ after you reload it. It's called Koans. Now this one works differently from, you need to make maybe wrapper accessible. This one works differently from the other projects. There isn't like a command line. Well, there isn't like a command line program that you run. Instead, what you do is you do the following. You say maven w exec java, and what this does is it starts a little Java program that doesn't terminate, and what it'll do is prompt you to answer one of the koans. So let's before we dive into that, let's go back to IntelliJ. Actually, let's not. Let's quit this little program here and let's check in the source code first. And again, git add pom.xml and the cone. Git commit added Java cones. Git push. Now let's go back to the cones directory, run that exec Java command again. Now, what is it telling you? It's saying, hey, you need to begin, you need to open the file, blah, 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 about cones. There should be a method starting with @cone called find about cones file. Look within it for your first lesson. Once you have solved that, save the file, check back for your next lesson. Okay, so we're looking for a file called about cones. Okay, let's go to IntelliJ and let's go to the Git and like refresh our view. Now, oh, yep, it looks like it's found a cones directory right here. Now we could navigate through this to find it, but we can also use the, what do you do? Sorry, where is it? The navigate to file and say about cones. Oops. .java here in source beginner. Okay. So the cones files look a little bit like unit tests in that they're annotated with something, and they have these methods that are annotated. So right now, if we go back to our terminal, it says, okay, that there is ponder what's going on in the about cones classes, find about cones file method. Okay, let's see here. Find about cones file is calling the fail method with delete this line to advance. Well, what do you think we need to do? We need to delete this line. So if we delete this line, it'll auto-save, and now we go back to the command line. It reloads the file, and now we're moving on. We have accomplished one of the 269 cones. So let's see here. A cone is considered complete when it no longer throws an exception. Often there is more than one way to solve a cone, but only one correct way. This is often hinted at within the cone itself or the comment appearing here. Ponder what's going on with the about cone class's definition of cone complete method. Okay. Definition of cone completion. Boolean cone is complete equals false. If not, cone is complete, fail. So what should we do to make this cone pass? Sorry, I heard someone say something. True. Yes, so if we change cone is complete to true, go back, it tries to evaluate again, and now great, we've done 2 out of 269. Now it's saying, hey, okay, it's telling us about the 2 underscores. The 2 underscores are an attempt to communicate the need to fill in an answer. Judging by context, what should double underscore be replaced with? Ponder what's wrong in the about assertions classes, assert Boolean true method. So now we need to go to about assertions. So navigate to, well, we can go to a class of a file. We can say about assertions. Okay. Assert Boolean true. There are 2 possibilities, true or false. What would it be here? So we want to replace those 2 underscores with the value true to make this assertion true. And now we're on number 3. Okay, there's another assertion. It said, let's see, line 18 may offer a clue as to how you may progress. What went wrong? Such as false, but was replace me. So sorry, line 18. So line 18, if we expand this, is assert false. It's underscore, which actually has the value, has the value replace me. It doesn't say that, I guess, here. So we need to change this false to false. Yes. And now we're at number 4. So this is what you do with the Java cones. There are all these little methods, and like I said, there are like, there are like 269 of them. It takes a while to get through them all because they do get harder. But these I found are very effective at giving you just the fundamental little pieces, parts of the Java programming language. So I'm not going to lecture you about all these different things in the syntax. There are some lectures there that you can follow along, but I found this is a much more practical and applicable way of working with the Java codes. So, we've done these, and so now I can commit the changes, started in on Java codes. Okay. Oh, sorry, I just committed that using IntelliJ. That's the fast way of doing it. And so anyway, so this is, you run this from the command line. Let me go back here. And I guess, just some things to point out. This isn't meant to be a race. So granted, there are a lot of them, and probably, you'll get to a point where it's like, oh, I just want to make it pass. But really, what I encourage you to do is to start working on them now and just do a couple every day, right? Because they're not due until February 9th. So you've got like an entire month to, actually 5, I guess that's 5 weeks? Yeah, 5 weeks to do them, because there are a lot of them. So, explore them, and, if there's one that seems a little tricky, or like, hey, you tried a couple of answers and it took you a little while to get it, think about, what it really means. And feel free to ask questions about it on Slack. I think there is a Koans channel. Yep, there is. So if you got questions, ask them there. We'll talk about submitting next time. Oh yeah, and by the way, more so than even other projects, but for every project, before you submit it, you should run the Koans on the CS Apartments machine to make sure that it behaves the same way it does on your local machine. Because unlike some of your other code, there are a couple of these that might be dependent on your machine. I think I've gotten rid of them, but you never know. Oh, Eric did some math, like 7 to 8 Koans per day. Right, not so bad. So if you do 10, you can take a couple days off. It's yep, there's a lot, but here again, I recommend just doing it in the background starting now. Any questions about the Koans? Yeah. Oh, no, I mentioned the lectures, and sorry, I sort of went off on a tangent there. So I'll reiterate that. I'm not going to, like, in class, tell you all about the Java programming language. That's something that you've already got an introduction to. There is, if you want to learn about the language syntax, if you want to learn about, how primitives work and bit shifting and all that kind of stuff, there are other resources. You're probably not going to really need them for the class. The Koans are a good way to learn that, and it's a way that's not like listening to me talk to you, but you actually get to explore them. That's where I find them so valuable. Okay. So let's see here. I think we've covered all of the content for tonight. Yes, we have. And it was a lot. So thank you for bearing with me. Let me quick reiterate what are the things we covered. First of all, we just talked about the class itself, right? We went over the syllabus. So then, that's where we talked about sort of the general shape of the class, the kinds of things that we'll be learning about. Then we got a little bit of an introduction to test-driven development by watching that Uncle Bob video. And then we played also with GitHub. Now there's lots of stuff on the Getting Started repository that I didn't go into. Some of it I'll cover next time, but please take some time and read over this document. Yes, there's a lot there. Yeah, there's a lot of words, but the stuff that I've found over the years is necessary for most students to configure their environment, to be able to work with the code in the class. So I put this here for your benefit, and let me know. This is actually, I've only been using the Getting Started repository for a couple of years, and I'm still finding that there's more iteration that I can do on it to improve it and make it more useful for you. So if you found like, hey, I read over this and something wasn't confusing, or hey, I read over this and I didn't answer the question I have, let me know because I want to make sure that this is a good resource for you. And so, please go home and start playing with this stuff to get your environment all set up. Let me know if you have any questions. I encourage you to post them in the Getting Started channel so we can have a focused conversation all about getting off the ground here in the course. So we did that. And from there, we created we ran the Create Project 0 script to create the code for the student project. And we will dive much more into this next week. I think next week we'll be working primarily with this. I'll be doing some test-driven development with you. We'll be learning about unit testing. We'll be learning about integration testing and what the differences are. So we'll be filling out some good stuff there. Then thank you for sharing all of your experiences with remote learning. This is some good stuff. I'll study this between now and next week and look for opportunities to leverage your learning to provide a better experience. And then finally, we focused in on the projects for or the projects that are assigned tonight. We looked at project 1, which is the beginning of our Java application, writing those fundamental airline and flight classes. And we also finished off by talking about the Java codes. And that was a lot for the first night. Thank you for bearing with me. I'm sure your brains are very full. I know I'm pretty tired right now. I'm looking forward to going home and crashing into bed. I will let's see here. I will look for me to post the recording for tonight's class. I'll try to get it out tonight. We'll see how long it takes to upload, but I'll definitely have it out by tomorrow at noon. Any concluding thoughts or final questions before we break? Nope. Okay. Thank you again. Welcome to Advanced Programming with Java. I'm looking forward to the term. Stay safe, stay warm, and take care. We'll see you next week. Bye, online friends.